Yes, I needed a hammer.
Need a hammer.
Something. I have Gav here. Slightly off screen.
Oh,
no, other way.
Other left.
The other left. Good morning, everybody. Yes, it is two of us here today because we're going to be working on a project that Gav has been working on for a little bit, and he's got some ideas, but we'll get to that in a moment. First, I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. And just up to start with, start thinking about nerd brags, because they can throw them in anywhere along. Don't wait to the end. Yes, Gav is the hammer. Yeah, okay, so many of you.
Hi, Gav.
It wasn't John's fault. For the record, they moved the buttons.
They moved the buttons. There was an OBS update and the streaming interface changed.
I'm just signing the stat deck over here for him. Definitely not John's fault.
Yeah. So many of you will know Gav from the barbecues. You'll have met him in person. Many of you will only know him from the chat. So this is the Gav that you see in the chat from time to time. Where is it? Gav went to the other left to start with. You went to the regular left to get in frame. Okay. Where are we?
That explains it.
Camera's up there.
Oh, that's where I'm looking.
Johnny wants to see us dance. Nobody else does.
Like those two chickens on that YouTube channel.
So good morning to Michael Wires, Crispy and Pete. There's me. I always pop up in the chat. It's too early. It is too early. Sharky, Imi, good morning. Stephen 44799 and Stephen George. Both the Stephens are here. Amanda, welcome. John Whips, SK Photo Guy, Tech Nebulous, Mark Laguda, Grant Measles, Russell Rennie, and Johnny Bergdahl. Welcome, Johnny of the 44 month membership. Okay, yes, you are right. It is way too early for this.
It's sunny this morning.
It is.
It has become sunny.
Sunny. No, that's a lie.
It was foggy, now it's sunny.
It was very foggy. Driving here this morning, you took a photo in the fog. Mm-hmm. I took some photos. I shouldn't admit this, but I took some photos driving over here because the sun was just like a glowy orb, and that was all you could see of it.
You did pull over and stop your vehicle
I did.
First. Of course you did.
For the record, of course I did. SK Photo Guy says it's 6 p.m. for me and too early for this. Michael says, Melbourne has been super smoggy all week, which has resulted in some spectacular sunsets, I've got to say. Last night's sunset was like...
Let's all go back to bed and try again in a couple of hours.
Yeah, okay, Crispian, let's do that. Send more money, says Pete. Here it comes. Is it going to catch up? I think it will.
John?
Yes.
Yep. Oh, another dance. Okay.
Another dance. No. I'm not going to dance every time this happens.
I need a chicken suit.
I don't have the energy for that.
I'll do it.
Okay. Gavin is a designated dancer.
Yeah.
He's my backup dancer.
Shekels.
Backing dancer, whatever. Yeah. Whatever the term is.
I'm the talent.
Yeah, he's the talent. I'm just the producer.
I'm something.
So...
I need some Pete sounds, yeah.
The chat needs Pete specific sounds. Maybe it does. Yeah, Cast Note could have specific sounds built in, but only when RelWare does something. Yeah, I'm already wearing my chicken suit.
That's because your squirrel suit's in the wash.
It is. 1 a.m. is still 22C, says John Whips. What part of the world are you in, John? That does not sound right. Okay, now, what is going on here? What is going on is Gav.
Oh no.
Oh no. Okay.
Here we go again.
Yeah. Yes, Crispian. That is all you need to do.
And you can
To
watch
get
this
Gav to
later,
dance.
is the thing. You can watch this again and again.
Oh. Okay.
Where do we go?
I've got to
with this?
reset my brain. What is? All right.
Right, why are we here?
Normality is resumed. Has resumed according to Trillian.
Mm-hmm.
So, why are we here? Now, for those who don't know, Gav, how
Mm-hmm.
about you just give a brief explanation of what it is that you do that has led you to this project? Like, why is it that you want to work on this
Okay.
project? And then we'll talk about what the project is.
No problems, John. No problems at all. Oh, get over
This
this,
way,
side.
this
Get
way.
over this side a bit.
Yeah.
I teach at a TAFE college, Technical and Further Education College, called Box Hill Institute. Used to be a TAFE, now it's an institute. I don't know what that says about us, but anyway. Marriage is an institute too, isn't it? Interestingly. So basically, what we've got is we teach, in my case, electrical apprentices, or pre-apprentices, in fact, as well. So we have the apprentices coming in to learn about electrical. We have the pre-apprentices coming in to learn about how to become an apprentice in order to get a job to become an apprentice in order to come back to the TAFE.
Okay.
Okay.
Interesting.
So, and there's ones for carpentry, and there's ones for motor mechanics, and there's ones for stuff. And there's also another one which is called Vet in School, which is a Victorian initiative. And it is for year 11, year 12s to complete the pre-app course over the duration of 2 years as part of their schooling. So they come in one afternoon per week and they participate in the electrical pre-app at that time. So we've got one class runs over 2 years. We've got another class for the pre-apps which runs over 10 weeks, which is very compressed. So that's every day. So it's 1 day per week for the school kids on Wednesday.
So that's the 2 year.
That's
program?
the 2 year one, yep. And they can finish that early and get a job and go out there and make a meaningful living and become a electrician apprentice, because we need lots of those. We also have pre-apps, which is a Victorian free TAFE initiative at the moment, and that's for us to get more electricians in to become apprentices again. So that is a 10-week course, and that's very popular, being on the free TAFE list. And it is really intense. There's a lot of subjects in a very short time. And also the electricians who are apprentices, over their 3 year, 1 day per week course, they come in 1 day per week to the campus and they learn their subjects over a 3 year period. So we've got a 2 year period, a 3 year period, and a 10-week
10
period,
week.
all
Yeah.
occurring with the same or similar teachers. We've got A grades teaching the requirements for the A grade electricians. We have myself and my team who are the pre-app team, and we work on the pre-apps, which is the guys coming in for 10 weeks, and also the guys who come in for the 1 day per week as part of their school related activity. So it's good. And we have a subject. So what brought this one is I've got this subject I was presented with, which is all about refrigeration. And it talks about how refrigeration works. And my boss, because he's a boss, said, Gav, you haven't taught this before, off you go. Next Wednesday, you've got to teach it. So I went through all the materials, which are quite good, and I realised I didn't know anywhere near enough about how that works. And I've got an air conditioner at home, and I had a pretty quick requirement to come up with something to present that the students could identify with. So if you're and we also, by the way, Box Hill Institute also has an entire refrigeration building designed specifically for the refrigeration guys. That's supported and provided by industry. So they give us working air conditioners for those guys to work on, which are mains powered, things like that.
So it's not just theoretical, you have actual
No,
installations.
there's
People can
full-on air conditioning
learn
systems
how
to
they
do
work.
a whole building, and all the connected units in little like pods
Okay.
that the guys do. So we have access to that. So I wandered over and looked at all this. I looked at all the different ways we can sort stuff out, and I tried to come up with something interesting for the students to do, because they were very heavy on theory, not much on prac, and not. The LMS is a computer-based system, as we know, and the LMS itself doesn't really explain well for a person who enjoys something physically to play with or to code with or something, how to make something work. So I presented that to our good friend Claude, because Grok was busy that day, and Gemini, he just wasn't talking to me. And don't even start me on Copilot. So I presented it to all four of them. Claude went, I'll take the gig. So we did. And he did some coding for me. And I gave that to you, John, earlier, didn't I? And as I went through it and learned and worked my way through it, I learnt about things. I got the code to teach me a little bit more about HTML, which was good. And I started creating a device. And the device can do certain things. It does need some sensors. It does need some information to work with. And one of the things, I was just chatting to John last week. I rang him, out of the blue, wasn't it, really?
Yep.
And I said, John, well, you want to take the story from here, sir, or shall
I? Yeah, so one part of this, what I've got open here is the process. And look at the little scroll bar. Oh, you can't see it. Hang on. I'm going to bring the scroll bar to the top because you need to... What? Okay, I have words to say with the UI people, but anyway, scroll bars. Why does nobody get scroll bars right? So this is Gav's chat with Claude talking about designing a system to what it is. Design an Arduino-based web display sensor that can show dry bulb, wet bulb, humidity, and dew point fused with an air conditioner to measure both in and out air values for a split system unit. So one part of this is measuring the airflow through the system. And I think there are 4 locations, aren't there? There is in and out on both the...
So you've got return air, which is the air returning to the room. You've got the in air, which is the air going into the top of the split system, which is then being compressed and chilled or dried or chilled or dried or heated or cooled. Depends on which way you've got it set up. And that goes on a set of pipes and gases to the outside of the building, which goes to a condenser unit or a compressor unit outside, which has a airflow in and airflow out and creates a differential on that as well. And then there is also what's called a mixed air ratio, which is approximately like 25% or something like that. I just used Claude to take the approximate values for that. And I got it to start building me some code, as you can see. So I was asking it to do this and do that and do this as we went through. And it got smarter. Now, I guess the background of this is there's a lot of information that I gave to Claude, which was handy, because I got it from the LMS. So I can't use the stuff out of the LMS, but I can use the figures, the charts, and the Excel spreadsheets and things which the student would have to manually calculate or work out, decipher, decode, and figure out. And I thought, rather than have them try and figure it all out and go, off on a tangent somewhere, a squirrel you could argue, in the wrong direction, then I will give them a web interface or something which can make sure that they can do things with it and understand why they're getting the values they're getting. So it started off very simple. That one there you're looking at now, John, has got A and a B, which is the, as you can see, the
so
air.
it's the indoor return air and the supply air out.
Yep.
Just those two.
Yep. So your return air, when we're talking about return, we're talking about the return, the processed air, if you like, returning into the room. Because cool air drops towards the floor, hot air rises, gets sucked into the top of the split system, passes through the split system, is pushed out again as cool or heated air as we go through. So that's very simple for us to understand. And as you can see in the Claude thing here, it got more and more and more sophisticated as it went along. So I started with a DHT.
DHT11.
DHT11 or 22. Yeah, I had one of those in my cupboard, and I thought, there's one of those. I can start with that. If I can use that as a sensor, that would be a good starting point. And then, as you can see, it gave me some suggestions. It designed a case for me. And then I went, well, hang on, let's update the sensor, expose this. Claude did what Claude does. And then at some point it said, we've made your shield for you. We've provided some firmware changes. Here's the wiring guide. And then I said, well, how about a BMP 180? Because I've got one of those as well. And then it gave me the option here, as you can see. So you've got the DHT 22 and you've got the BMP 180. and there's an SHT31, which is another option. So it came up and recommended that one. And I went, oh, that's interesting. This one's got more features and does more things. So there, I'm just keeping an eye on chat as we're going here.
Yeah.
So there's I2C wiring involved on a shared bus, and as this went along and developed, it kept on suggesting, you know, a few more dollars for this, a few more dollars for that. And then I just kept on making this poor thing more complicated and more complicated as I went along. So it's evolved over a couple of weeks. One part of it was the web page, which allows you to simulate locations.
Yeah, shall we have a look at that at this point?
Sure, absolutely.
Yep. So what we've got here is a web page which is a static HTML file. So you can just load this and run it. Everything happens in the browser. And what I'll do is do you mind if we put this
No, the
URL
guys are welcome
in?
to this. I wrote it for a good purpose.
So this is the URL. What I did was just take a static HTML file and stick it on the Superhouse web server so that it's publicly accessible. You can load this up right now and play around with it. And yeah, you can grab things, move them around, and it updates all the calculations. And you can do different locations, so you can simulate different weather conditions and how the system responds.
Yeah, so we started off in Melbourne, originally, just Melbourne currently. And then I went to work and said to one of the guys, I've got this, and he went, that's very nice, as our teachers often do. We rib each other a little bit. And he went, what about the seasons? I went, oh, good point. So I went back and looked into the seasons. I went winter, spring, things like that. Worked out we've actually got 6 seasons in Melbourne, apparently, according to the Bureau of Meteorology.
Summer hot, summer humid,
and you can see the references there for the different locations and the time of year, and that's all data from the airport, I think. Because when you hover over, it'll show you the location. So John, back up there.
Back up here.
Yep, there it tells you where it came from. In one of those.
Oh yeah, Melbourne Olympic Park was that one.
Yep.
That's Olympic Park.
Must be Olympic Park, that one.
Yeah.
So then my friend told me that's lovely, but we live in the southern part of Australia, so therefore it's going to be more Darwin based. It's leveling the numbers. Yeah, I think it is. So then he said, oh, well, why don't you look at it? You know, that's very good, because in Melbourne we deal with quite a lot of, we don't have too many hot days. We have quite a lot of average days, and we have a lot of cool days, you would argue. So our winters it's much easier to stay cool with air conditioning in the summertime for those couple of 45-degree days we get at the changeover of the seasons. But most of the time our air conditioners are going to be on heat mode during winter, keep us warmer.
Yes.
Which is when they're least efficient. Okay. So he was saying, well, look at Darwin, because it's got the wet and the dry. So we looked at Darwin, and we looked. You can see in here I did the simulations. Got Claude to do some simulations in here about where it would be, and again I got it to look at the seasons to find out, and grab the Met data because he suggested that was a good place. To work out how the weather changes between Melbourne and Darwin, for example. And then, of course, my good colleague Renee, the trainer, said to me, okay, that's lovely, but that's not the hottest place in Australia. Go find that. So
there is a fire here, Marble Bar, I guess that's...
So, yep, one of them is Marble Bar. So there's 2 contenders for the hottest locations in Australia. One of them is the hottest day, as such, and then the other one is the longest duration of heat. So the amount of days consecutively when it was hot.
Yes.
Which means that we get a lot of heat build up and load generated over those days before the change of weather. So one of them is Marble Bar in WA.
Yep. Which is
in the
my grandfather was a pilot who flew out of an airbase near Marble Bar.
Oh, okay.
Yes.
There's the squirrel. We were waiting for the squirrel.
Yeah, this is the
there
squirrel.
It is. Okay, we've got a squirrel today. So Marble Bar is one of the places we can look at. And we can also look at Unadada, which is in the desert.
Yep.
In South Australia. So that's the one where I think that's got the hottest day. So if you put the mouse over there.
Over there.
Yeah, and it brings up wherever that thingo, there we go.
Oh, when you're down here, summer
Yeah, so-
typical.
Yep, so you've got your
We
different
go
different
for
locations.
summer extreme. Let's go for that.
So one of them here says this is the hottest day, and the other one says it's the longest duration. Depends on which one we're looking at. So probably summer typical or something like that will say. In one of these, it actually tells you where the reference for which one it is. Sorry to lean forward. And Marble Bar has the same one. It'll describe Marble Bar, and if you put your mouse over one of these, Claude will come up and say it's got the longest day, I think.
Spring.
Driest
Building.
months.
Summer.
I noticed it yesterday when I looked.
Australia, one of Australia's
Australia's
hottest inhabited towns.
Yep. In the Pilbara. Yep.
Oh, famous 160-day heat run, 1923-24, with every day above 37.8.
Longest
Average
heat wave
max.
in world history. Okay.
Average max exceeds body temp for 6 months of the year. Oh.
Yeah, it's pretty warm out that way.
That would not be nice.
Okay, and the other one, if you look at it in the data by comparison, and it will also say the history stats on that one to give us a bit of feedback on that one. Yes, John, you're right. Marble Bar has the longest heat wave. Now, just to contrast that, because again, Renee, my fellow trainer, who's a lovely guy, went, okay, that's the hot you've dealt with, your Melbourne you've dealt with, the Darwin you dealt with. What's the coldest place? So then I, of course, had to go and find out where that was. And that is apparently Charles Pass in New South Wales, which is up Kosciuszko Way, up there. So again, we can look at the different temperatures and different sections of the 6 different seasons of the year. And we can look at that and see how things perform.
Okay, so I think you need to give a little bit of an explanation of what we're actually looking at here. So we've gone through a number of different locations.
So locations are good because they'll give us indicative stuff.
Yep. And then we've got different seasons for each of those locations.
Yep.
So the numbers that we're
So
seeing
we can
in
turn
here,
off some of these. That's the nice thing about this web page. All of those buttons that you can see can be turned off. You can switch off features in here one at a time. You just keep turning them all off, John, until there's nothing.
All right, let's.
Now, again, I'm still
everything
trying to
off.
figure out what Claude did here. But we can just select one. So let's select Melbourne, for example, and we'll pick, I don't know, winter. It's a good time, or
Winter.
autumn. What does it say? Now, if we put our mouse over the winter a bit again, what does it say? June, July. Are we in July? June, July? Okay, June, July, long-term mean design degree minus
1C, 95%
humidity, heating mode operational, condensation common on cold surfaces, which is what we had this morning.
That is our practical experience.
Practical experience. Okay, so now we can turn on, for example, if we go to the left-hand one there, that is the, is that the return air?
return
So
air.
that's the air coming through the, sorry, wrong side. Coming through the processing on in the split system and coming in back into the room, the part that's heating or cooling the room itself. What's being pushed out through the fan into the room.
So where it says 21C, is that the target temperature?
So that,
or the...
so you can adjust that from 15 to 18 to 20,
Okay.
and you can move the humidity vertically.
Okay, so with this,
you
we can
can-
set what our target is.
Correct,
So
yeah.
if we wanted to achieve, for example, 25%, 25 degrees
at
at
50%
50%, we'd set
humidity.
it there.
Yep.
Or 20, let's make it 21 at 45%.
Yep. Okay, and then we would also next up bring the next one up, which is the trying to read this
The
from
Zone B supply air.
So that's the air coming in at the top. What air temperature would be coming through there?
Okay.
So we would have to measure that. This is where our conversation about the item coming up later comes in.
We're going to be building a bit of stuff today. We're going to see the scope. We're going to, this is all the backstory to the actual device we're about to experiment with.
So, so this is the temperature. We need to also locate that by measuring it somehow. Okay, so we would put some sort of a sensor on the top of the air conditioning unit, and we would measure the humidity, the temperature, and work out the relative humidity, the dry bulb, and what's called the wet bulb. So if we put a wet sock over the top of it, and put a thermometer there. That's called a wet bulb temperature. Okay, that's traditionally what they did. We can simulate that electronically by using the humidity in the air and saying,
Okay.
so if it's only 50% humidity, what happens if we use mathematically, create it to normally 99, 100% humidity? How does that affect it? Once it's achieved 100%, I guess we get dew on the ground because the moisture falls from the air to the surface, pushed down by gravity, lands on the ground, and we see dew. Or fog is pretty close to it, which what we saw this morning.
Yes.
Okay.
So this line that we're seeing here between A and B, this is essentially, it's a two-dimensional delta, both in terms of the temperature on the horizontal axis and the humidity on the vertical axis. So this line essentially represents what the air conditioner is trying to achieve.
That's the values. That's the values you are receiving back from the items. You can tell it to change the temperature and it will try and match the return air back into the room to that, which is going to give you your value. But as you can appreciate, over time, things affect other things. So, we can say go down to 20 degrees or up to 24 degrees. It has to change the humidity and change the airflow and all sorts of things in there, and we've got our fan speeds and stuff involved.
Yeah, those parameters all affect each other.
Yeah, so the unit will do certain things based upon what's required there. Okay.
Oh, Mr. Fixit just said, how would you add a different city to the psycho chart? Like if I wanted to use the chart in my city?
Well, at the moment, unfortunately, we don't have a manual chart, but you can manipulate the one with the closest city to you, and then you can create a psycho chart of its own. So you can manipulate these figures as John's doing now for your actual system to do it. Okay, and my logic was I'd like to build some sort of a sensor system that I can plug in wirelessly, ideally, with this modern electronics we have, and be able to take a log of the air conditioning situation inside the building, as we are now. Here's my head off the screen again. Sorry, I'm not paying any attention to the screen. I'm looking at that screen. Be able to monitor and record the values so I can then have a look at the trend and see what things going on, and then work out whether my air conditioning system design is ideal, sub-ideal, or barely going to cope, shall we say, because we will have certain conditions will occur if we do it. If things cannot be managed properly, the humidity, the air temperature, all that sort of stuff, that is in the design of the air conditioning, which is kind of what my students are wanting to learn a little bit about but not become experts. Okay, so for them, they can do that. I did everything was manual before I started putting in these presets, and I think the code is on Claude. That's shared at the moment.
Should we share this as well?
I'm welcome to share that. Yeah.
Okay.
It's best to know the journey and where the road led to.
Stephen said, so John is building his own controller for his aircon unit. No, I know, I'm not falling down that rabbit hole. This is just about some sensors to be able to measure how the air conditioning unit is performing. So what I'm going to do is drop a URL in the chat, which is Claude. I've got to try to type sitting kind of sideways. Claude session, creating the is it a psychometric chart? Is that how it's psychrometric?
Psychrometric, yeah.
Psychometric,
I think it is, yeah.
And sensors. So psychrometric, yeah, okay. So this link will take you to what you're looking at on the screen now.
And if you guys can confirm you can see that, that would be good. And then we'll say it's all good and we'll be happy with that. So this is the journey of my design, and you're welcome to share it, use it, enhance it, help me come up with a better idea. It's just grown and grown and grown. So it went through different types of sensors, and then it went through different options, and I've kept on going through and going, I want to use a Fire Beetle, which is a DF robot unit, and I've got an 8266 version of it. And then I've looked at a Fire Beetle 2, which is the new version, which is based on an ESP32. So all the way along, I've done all of these design changes and given all of this work for our friend Claude to try and figure out.
Yeah, and as you can see, there are So it looks like back
And
here.
I keep running into the
these are
typical.
earlier versions.
I keep running into the "you've exceeded your limit" message all the time. So.
Well, I'm not really surprised because look at this. I've been scrolling for all of this time. Look where the scroll bar is. We've barely moved off the top. This goes on and on and on and on, and we're still barely off the top. So there has been a lot
So
of.
that's about 2 weeks of me using all of my Claude time to do this, coming up with something useful and going, oh, do you mean this? Do you mean that? I've got to modify this code. And of course, Claude does what it does. I did change from the models a few times to try and get I wanted to try and limit down the amount of tokens it was asking for to try and maximise my time. And yes, it was interesting. I just kept on chewing it up and getting up at ridiculous amounts of time in the morning and going, okay, it's 3 o'clock in the morning, that's when it renewed. Continue, keep doing this stage. So it was more a case of just wanting to do things. And yeah, so down as we get towards the bottom, I've added, like yesterday, I was looking at it going, well, one of the most important things about it is also altitude. Right? So there's a whole lot of stuff in there.
I'm now maybe 1/3 of the way through this.
Yeah.
So I'm going to grab this and drag it and drag it and drag it and take it down to the end, and then we can work backwards and look at the more recent parts. Yeah. Okay. So.
So your suggestion, I said to you last weekend, could we make this work with ESP Home and Home Assistant? And you said, yep. And I went, okay. So of course I presented that to Claude, and he went, yep, can do. And I said, I've got more than one sensor of the same model number. And he went, oh, that's a problem. You might need a MUX or something. Is that what the right word is for it?
Yes. Yep.
Okay, some sort of a MUX,
Multiplexer.
multiplexer. Yep. So it's saying, oh, you can use this one, and you can use, there's a break, there's the part there, TCA, what is it, 9548A. John probably knows that number backwards and frontwards.
That is what we used in the Testomatic.
Oh, okay, sweet. So then, so basically it's saying you can add this in, you can remove this. Why did I put MOSFETs in here? Somebody's going to look at this code and go, why did you put MOSFETs in there? I can't remember why. I've never used MOSFETs before. And I thought I might be able to control a light or something. I've got some LEDs. So excuse me. Got some LEDs which are for outputs to indicate things. I just wanted to make is there such a thing as a purpose-built universal device, John?
Oh. Maybe purpose-built universal. Yeah.
No, John. The institute doesn't fund my sessions, but the taxpayer will, because this is going to go off my tax at the end of the year as a resource I need to use for my training stuff. So somewhere along the line, I don't lose. Is probably the message. So yes, a few things come into effect here. Altitude, because the air pressure is less as we go up in height. Area of the room is another factor. The amount of people in the room. So as I went through the software in the web page, I know John's in here at the moment, but in the web page it can simulate things like, so you've got a couple of bits at the top there. You've got your psychometric chart, which we're talking about. Yeah. There's a room load calculator, which you can work out the length, width, and height of the room, which are all on slide bars. So you can slide these slide bars back and forth. 5 metres by 6 metres by 2.7.
Yep.
And you'll see the other slide bars below it change. So if you make the room bigger, you'll find that the slide bars below it will follow.
Oh, they do too.
Yep. They track that. Amount of occupants, amount of equipment.
Airflow,
Yep. So you can work it out. I think there's little, if you scroll down a little bit, there should be a little rectangle showing you the area down there.
Oh, down here.
It was Claude's version of it. It wasn't horrendously important. This calculates all sorts of things. So as you go and modify the settings in here, you can modify it to suit your individual room. You can get an ultrasonic range meter, which is what I can do with the students. So, because I don't know which room I'm going to be into, and I go, oh guys, here's the laser measurer. Measure me width by height by that.
Yep, you put it in here.
Work out the volume and the area of the floor, and do that, which happens to line up with one of their subjects about using maths and intermediate computational maths for engineering. So they do a subject early on about maths, and this reinforces that knowledge for them. So
Or
they
it
go,
gives
oh,
it a practical application.
they apply something a little bit further down the track, which is good.
Yeah.
So I blatantly borrowed all the values out of the software which we use, and I'm sure they don't mind because I'm not actually stealing anything. You'll find there's a next one there, location and seasons is one, and your chart. So under your chart one, so that one there is the.
Switch this out of dark mode.
So,
No,
yeah.
that does not make it easier to read.
No, I tried to get it to make it something like white. Maybe somebody in the chat can tell us how to get decent colours. So I think psychometric chart shows, if we go back to the left there.
Right, I'm just going to try it because I'm aware that on the stream this is going to be very hard to read. Even if we can read it here, it's going to be tricky on the stream.
So if you go to the left-hand tab up there, yep, there's 3 tabs below that. You've got chart, which is that one you're looking at. Now if you go up again a little bit more, just
I
above
see,
Melbourne,
yeah.
you've also got the calculator.
Calculator, yes.
Which will work out the dry, so you can put in your return air, your supply air, your outdoor air, and your mixed air ratios, and it will dynamically calculate those for you and adjust them. So if you move any of those, John, so if we know the temperature inside here on the return air,
Return air.
so we can, if we can measure the return air temperature
Say it was,
coming out of your air conditioner,
Yeah, say it was 19.
so this might help the question about my particular region. You can set them manually.
So the numbers down in the bottom right are changing as I move this backwards and forwards.
And you can move the humidity, and each one will dynamically change. And you can see the balanced relative humidity on the right, and the mixed air values will change as well. So that's the return air coming back into the room. Time for a dance. Oh, another dance.
Oh, he's going to dance off screen.
I'll dance on screen. People pay money for this.
It's way too much energy. Stephen said, get the Institute to get you a $100 a month plan. Claiming it back on tax is still an expense for you.
It is, but I've got to wait till the end of the year to get it back. So I'm on the $40 plan or whatever it is at the moment, and that's good enough because otherwise I'd spend my life in there. And
you got to run out of tokens, otherwise you'd never stop playing with it.
You're like,
That's the rate limiter.
You'd find me, lying on my keyboard dead because I've been doing it all night and day. And it's like gaming. I don't want to do that either at that level. So I appreciate that, Steve. I really do. So you can adjust this according to your actual measurements you can get.
And also, this is what you were just talking about with things changing with altitude.
Yep.
So as I move that, you can see the numbers down in the bottom right are also moving. No, Henrik!
Hendrik.
We're giving Gav a workout here.
I don't have to go to any gym. Okay, I get it.
No, here it is.
Here we go.
A banana peel. Henrik. Oh, and Pete said, wait until Gav learns about sub-agents in a CI DevOps-like environment. Oh yeah, that's just a way to burn more tokens, isn't it?
Yeah, well, institute-wise, we've got Copilot, and I gave Copilot a look at it, and anyway, look, the less I talk about Copilot and how much success I've had with it, the better.
Okay.
Okay. So you can adjust your altitude here to suit where you live. You can adjust your values of your return air, your outdoor air, your supply air, and it will calculate the mixed air from that based on a formula. And then on the next tab is the different formulas. So I asked, again, Claude. Claude gave me a lot of highly mathematical things, as you can see. P stat equals 0.61 times e to the power of blah, 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 times time plus t, whatever. And I gave it to a pre-app, and this is the good version, okay? So the veteran school kids are probably doing maths in school, maybe advanced maths, and they go, oh, I sort of get some of those, yeah, cool. And the pre-apps, they can be kids who struggle with school and don't like maths and, basically trying to work out the world. Nothing against them. We all were young once. We all had to make decisions. Some of us made really good ones and knew what we wanted. Other people floated around trying to figure out what they wanted to do in life. And therefore, what I did was I said to Claude, all right, make this formula description something I can relate to a student who's about 16, 17, 18 years old, thereabouts, who doesn't really want to be there necessarily, but they're doing it as part of a course. They want to get the subject done. They want to learn a few things. Not to say you get what I'm trying to say.
Yeah.
I'm not degrading the people. I'm just saying.
No, you got to express it.
Yeah.
Express the information.
Yeah, there's personalities
in a way
involved,
that
and we've
is,
got to turn it into
comprehensible.
something. Yeah, and that's something that a TAFE vet student, pre-up student would understand. So we tried to relate it because they do electronics.
Speak people's language.
Yeah. So you see, it says, what does it say here? Buckets minimum.
Maximum fill line. Yeah. Okay, so this is an explanation of moisture being held in the air and how much you can hold. So that's how relative humidity works.
Yep.
Yeah.
And then there's a worked example, which is some values. And then there's on the job why it matters. Hot duct surface becomes due to no condensation. Just have a look in the chat. Just woke up, saw Amanda's $2. I thought it'd be...
Mr. Fixer says, I was checking out installing a local model using GLM 5.2.
Personality.
And Grant says, Superhouse now rating is the top YouTube dance channel.
That means the benchmark is really low. Okay. So again, I would appreciate if anyone's got any feedback on perhaps this formula to explain it in a simpler or more relatable words I could replace maybe some of these based on if the guys have got some experience or can offer some suggestions. I don't think some of these are ideal. I think they're okay, but I don't think they're particularly ideal.
Yeah, I think these explain it. Well, I haven't read them all. I've just sort of been skimming through as I've been scrolling. But yeah, I like these explanations, particularly for... So I don't know about this, is what it comes down
Nor
to.
did I.
And so I need these sorts of explanations in order to understand the basic concepts. And then it's very easy to get lost in the calculations and not be able to relate it back to what does this mean? What is the mechanism that these calculations are representing?
How would I see this in the world?
Yeah, how do I see this in the world?
How do I see it in my head? Yeah.
So this is really nice.
So we have this different parts of that chart, and that's what this has done. So we have what's called a sensible heat ratio, which is the fraction of the total cooling that lowers the temperature as opposed to removing the moisture. Like power factor in electrical, it tells you how to the efficiency, tells you how efficiently the system is matched to the actual load type. So it's saying in here it's sensible. 100% is no dehumidification. 75 is sensible, so that's what we're aiming for. And 50% is late and very humid. And that's one of the buttons you can turn on and off in the web interface. And one of the bar graphs there shows that. So it says on the psychometric chart, it relates it back to the psychometric chart in this case. And then the ADP and the bypass factor, how clean is the coil? This is real, this part here down the bottom with some of these, I just let Claude go with it. Because it was probably more relatable to our air conditioning friends over in the other building. The guys who are actually doing this in the field every day as opposed to the people who are learning. So we've got air density is hot air is denser, that kind of thing. So there's a whole bunch of stuff in here to do with that. Bit scary, isn't it?
Yeah, there's so much to it.
So I tried to create the universal Swiss pocket knife of information that we could use here.
So this is for a course that has just been handed to you to teach.
Yep.
What material were you given access to? Were you given access to any explanations like this?
There are two different systems we use. One we pay for, as the Institute pays for. I don't think that's any big secret. And it is very heavy on theory knowledge written by electricians, from electricians' point of view. And we also have, which is an external resource. And we also have an internal resource which is written by our actual refrigeration teachers. So the product called Moodle, is anyone aware of that one?
I'm familiar with Moodle.
It's an
yes.
LMS system. So both of them use Moodle. They're just written differently, and they present different looks. One is very generic, standard Moodle out of the box, and the other one is a slightly modified version, which we call Student Web at Box Hill Institute, which is a more friendly, studenty kind of thing. So, are we running behind on the chat, are we? Are we doing Scrum, baby, Scrum. Yeah, there is Scrum in there as well. There's all sorts of stuff in there. I got it to do all sorts of things. I might make a Scrum package for Moodle. You might see that in there somewhere as well. So, and I did import it into a Moodle install, and it did work. So, that was probably the thing that Claude did really well. Now it's not very good at KiCad. In my particular case, I think we found that out. John and I worked out. And the other thing down here is the ASHRAE, which is the comfort zone. Is the room actually comfortable? That's one of the other ones in here as well.
Okay. Defines a safe operating area for human comfort.
Yep.
Yes, okay.
So we need a heat sink to dissipate.
Not too hot, not too cold, not too humid, not too dry.
Yeah.
Okay.
Is today's theme behind the scenes? I'm not so sure about that. I don't think there's any secret about this conversation or this. I'm sure the guys at the office won't have any complaints about what we're talking about here because it's a side project, and it's not meant to be anything about giving me a subject at short notice. Sometimes that happens with teachers, and you've got to learn really fast.
Do the best
so that's where your ADHD and your really fast focused learning has to happen. Like I need to know this in 3 days, but I know nothing about this.
Crash course time.
What am I going to do?
Yeah, deep dive.
And then suddenly you're an expert in front of the students. So it's you could be the lead actor in a play and still learning your lines 2 hours before the thing starts, or starting a podcast and finding a new button change, like we did this morning. So yeah, there's a whole bunch we did in here, and I'm not portraying that I'm an expert on any of this. I just gathered all the tools together. I punched it at Claude, not out of desperation, but I needed to know stuff, and I wanted it to give it to me in terms I could understand. So that was it.
Sensible heat. Yeah, okay.
So somebody's asking, who determines the ASHRE? That's a good question. We might have to Google that one.
Yeah, it's part of the energy waste problem, as Crispian says. So I think, my guess, I'm reading into what Crispian is saying here. In my opinion, it is part of the energy waste problem. Perhaps what Crispian is saying is that the expectations of what is comfortable could be adjusted. And some people there are very wide variations as well in terms of what people feel comfortable in. Some people, a certain person I know likes a lot of heat. I don't mind things being a little bit cooler, so that it's definitely a range. What the ASHRAE up here, where was it, has a 21.5, 44 is what it's saying here, indoor comfortable. But there would have to be a range, I think. So Crispian, is that what you're getting at? For example, if you were using extra energy in order to bring the temperature up unnecessarily, or using extra energy to bring the temperature down unnecessarily, when the window could be made wider.
I think it puts the boundaries on, like your air conditioner has a maximum value of heat and a minimum value of cooling you can set it to, and I think it kind of defines those. And if you do drop back to the psychometric chart, John, it will.
Yep. If we come back up to
the chart there and enable that option, which is one of the options down here.
Oh, the ASHRAE. There it is. 55 comfort.
It'll put a little rectangle over there saying
there we go.
The window of what is what we consider comfortable air, which is somewhere between 20 and 26 degrees, and somewhere between 5 and 10.
Yes, but the humidity also varies depending on the temperature. So you can see that it's an oblong sort of shape here.
So you've got your dry bulb temperature in there. So that's your two values. Also mention a window, sometimes just opening an actual window is more efficient. Yeah, sometimes it is. Yeah. Just the motion of air and the molecules moving through the air will cool things down. And so we all know if we go to lock the house up and seal all the doors, it's going to be very hot in the summertime. We open the doors, and even though the air's outside hot, it will flow through the motion of the molecules. I think will make a difference there. Yep, heat mode of 20 degrees, says Stephen. Yep,
as a minimum temperature.
yep.
Interesting. So you cannot set a heat mode of below 20 degrees. Yeah, which is the bottom end of the Ashura range here.
And I'm just going to ask Steve, does he have a cooling mode or a mode above, or cooling mode above 25? Can we make it? Where is that other corner?
This is saying 20. That's right. This is saying 26 as the upper range. So I wonder if you could set the heat mode to 30 degrees, for example.
So there's some insight into refrigeration stuff. So then we've also, that's the inside temperature on the air conditioning unit, and then you've also got the third one there, which is the outside temperature.
Outdoor.
Which brings us to our conversation starter about where you and I were talking about.
Yes.
Where do we get things from?
And the practical thing we're about to do, which is, Stephen says 20 to 29 in heat. Okay.
So Steve's got a bigger window on his one. Yep.
Yeah. Yes. So what we want to do is start measuring how the air conditioner is actually performing, because with a typical air conditioning system, it's got its own internal controller, but you don't see any data in terms of volume of airflow or any of these other parameters that we're talking about here. And what Gav wants to do with his students is be able to demonstrate to them this particular air conditioner is running at this level and we're seeing this amount of airflow. So down the bottom, for example, here we can see the air density and all of these different figures, and we want to measure it and see it operating in a real system, not just simulations like this. So I think that's your motivation, isn't it? Am I misrepresenting it?
So, well, yeah, ideally, yeah. So what we do is we take the guys from our building, which is an electrical building, which is full of electrical stuff, electronic stuff, security stuff, and we wander across the road, literally, on Elgar Road, to the other side, and we go into the refrigeration unit, and I've asked our guys, our teachers in that area there, can I use their gear? And they said, sure, it's here. You can use it as long as we're not using it. You're welcome to use it. So we have a thing called a sling cyclometer, I think it is, something like that. It measures the air temperature, the humidity, the relative humidity. It calculates the wet bulb temperature, and also, what's the other one? There's 4 of them altogether. I can't remember the last one at the moment.
Yeah.
Relative humidity. No, I've lost
right.
it. I've lost it at the moment. So there's 4 of those, and it's called a sling cyclometer because you can actually, it's like you can swing it around like a...
you spin it around.
Spin it around in the air, which will create the air motion, so therefore it's got some sort of motion past it, is the thing. And it's probably a very expensive unit.
All this is a lot of hot air.
It is a lot of hot air, to be honest with you. Yes, but in our case, we've got to measure that, so we've got this device, which is very expensive. I imagine it's got $1,000 plus. And we also need an anemometer. And we've got the one from the House of J-Car for their $70 or $80 one. We bought 6 of those. And we also have a Fluke one, which is quite a big, expensive unit as well. And I proposed to John a question, which was, what was the question again?
The question is, can we make an anemometer by hacking a computer fan and reading the sensor from it? Some computer fans, the 3-wire computer fans and 4-wire, have power that goes to the motor that makes the fan spin, and they typically also have a Hall effect sensor in them so that they give pulse with modulated output.
Earlier.
Oh, here it is. So they give a pulse output. Where's the connector? There it is. This one's a 4-wire fan. And the controller, the fan controller in the computer, can measure how fast the fan is spinning. So it can do a closed loop control system. Instead of just applying a voltage to the fan to make it spin, it can modulate that to slow the fan down, to stop it sounding like a jet aircraft all the time, and just adjust the speed to pull out enough heat without working it too hard. So, and Grant says also look at a hot wire anemometer. Yes, okay. So that that was the starting point. Can
Left a
we
little.
use the can we use the output from the fan, and instead of powering the fan, can we just blow through it? Oh, with just for the
I was
fun
going
of
to
it.
say, where's your hairdryer?
Where's my hairdryer?
John's hairdryer.
I've got this little thingy here. Now, there is an issue with this, and that is that there is a motor in here, there are magnets, there are coils, and that has an effect because there is an electromagnetic field which is being induced, even if this is not connected to anything. So if you short the motor connections, it will act as a brake. But even without it shorted, you can feel a sort of ratcheting effect.
Kind of
and
cogging,
there
isn't
is
it?
the cogging, yeah, and there is resistance in the rotation. So I've got this little air compressor thing, so I can make it spin by blowing air through it. That's quite a lot of air though. So what we want to do is reduce that cogging effect and allow it to spin more easily, and read the output from the sensor and see if we can get something like a square wave coming out of this, which will give us the rate of rotation of the fan and make that a crude anemometer. That's the general goal. So we have a box of goodies over here.
Here's one we didn't prepare earlier.
Yeah, here's one we didn't prepare earlier.
No.
I am going to, how are we going to manage this? We're going to have practical issues here with the layout of the bench.
Hey, look, it's all about me.
Yeah, I can stay totally out of shot.
How did I
and
get
I can just, hello. So these are some things that Gav and I were playing with previously.
See how-
Don't give out voltage, they have protection in it.
See how easily I can manipulate John? It's really simple.
Oh. Yep. Henrik says newer fans won't give out voltage, they have protection in it. Okay. Maybe. Interesting. Maybe. Let's see. So we have a whole lot of stuff in this box, including this. So this is part of the mechanism out of one of these fans. This one is totally unmodified. This is the fan as it came. It's a 3-wire fan.
That's a very old dusty fan. by the way.
Yeah, so if we apply 12 volts onto this, we could make the fan spin, and we would get an output from the sensor wire there. This one is the same model of fan. I'm just going to move this out of the way. The same model of fan, but it's had its guts removed. And just for comparison, if I put this one on here, you can see that see how it's bouncing backwards and forwards? That's the cogging effect of the magnets and the coils that are in it. Now this one, which is the same model of fan, has had that removed. So it still has a magnet, but the cogging effect is gone. If it spins very easily, doesn't have much resistance, and it just slows to a stop. There's no like there is with this one, like that. So this is the mechanical structure of the fan. I'll move across just a little.
Yep.
And this is what we want to use to measure airflow. And the part that I had, where did I put it? Over here. So
Oh, and John,
this.
just to let you know,
Yes.
I bought some more during the week.
Oh.
And these ones are supper thin.
Ooh.
They're supper thin.
The
ones.
supper
Supper
thin.
Supper thin ones. So
Supper
if you're
thin
hungry,
mints,
supper,
yeah.
Supper.
Just
For-
have a thin, just one mint for
yes,
supper.
That's it. So that's the newer model of that old model that my friend gave me many years ago.
And it's a hydro bearing. Does that mean it's got water in it? Ooh, it's a supper thin fan with a hydro bearing.
Yeah, it came from the house of Amazon.
Okay.
And
So,
I didn't know if we needed two, so I bought two.
just in case.
Just in case.
You never buy one of anything.
No,
No.
because then I'll order another one later.
Yeah.
Admiral Walter said, is wafer thin.
Is wafer
Plus
thin.
fans.
Yes.
It is, yeah.
So this is the control, the PCB with the sensor that came out of the back of this. And this I think it can just be popped out, can't it?
Just push it, yeah. So you just
push it.
You just get something small.
Yeah.
And push the center bearing from the middle. And
Push
it just
this,
pops
and
out.
magnetically it'll
Yep.
drop out. Yep. Okay. And you can see that on here is the bearing that it spins on. And originally, this went that way, I think.
No,
Or was it the other way? That way, up? Yeah.
In there.
In there.
Yeah.
So this little black thing here that you can see, it just looks like a hole in the PCB on camera. That's actually a Hall effect sensor. So that is measuring magnetic field.
That's the motor driver as well.
Oh yeah, it
selects the
it's
coils to energise.
Yes,
the Hall effect.
and it has the Hall effect sensor on it. And what do you see on this ring here? That is the magnet. And if we put a sensor on this, like a magnetic sensor, we can find that it's actually magnetized differently at different parts. So it just looks like a continuous ring, but that is magnetized in a way that there are poles at different points. It is focused on the bench, and when I pick things up, that's when they go out of focus. So I'll try to keep things down on the bench.
Get rid of that.
Yeah.
Just in case that's upsetting things.
And so I'm going to put this back on there. And we are going to try measuring what happens when we put a sensor against the magnet that is in here and spin it by blowing through with a fan.
You can blow with your mouth as well.
And you can blow with the mouth, yeah.
Because the fan's designed to run at a very high speed and we're wanting to sense relatively low speed.
So what we're going to do is use this little sensor. So this is a Hall effect sensor on a breakout, and I've just connected some wires to it so that we can...
44H, I believe.
Could be.
Yeah,
I can't remember what the part number is on this particular sensor.
Yeah, there's a 44H.
Yep. And what I've done is just bent it away from the PCB a bit so that it is it's sitting proud by maybe 5 millimeters. And that means that it can reach in through the back of the case here. If I just sit it on this, for example, like that, it puts the sensor very near the magnet. And then we can measure what happens with it. So...
I'll move over, John, and keep an eye on the chat.
Okay, I'm going to slide over this way.
Optic pickup, says Mr. Out of the Box. Not in this case, it's magnetic. No, it is a Hall effect one.
Yeah, but yes, you're right. You could do optic.
You could do optic, yeah, that's possible.
Yeah, it's just this structure is not set up to be doing that.
Thin crust fan says...
Thin crust fan, yeah.
Thin crust fan, yeah. Hendrik says, say if the fans gave out voltage, there would be wind turbines everywhere, but sadly there aren't. That's probably true. We fix up the focus. Willing to go in detail on how you're able to remove the cogging effect? We've already done that, just joined. We can tear another one apart, John, just to go through that exercise.
We can.
So yeah, you do have to get rid of the cogging effect. That's rather mechanical and brutal, to be honest.
Yes.
But we're willing to do that. We're just those kind of people.
We'll sacrifice one for the cause.
That's it, yep.
Okay, so I'm going to...
The Gav Gav show. I don't
Check.
think that's true. But I appreciate it.
I'm going to check what this resistor is. I will explain what I'm doing in just a second. I just want to make sure that I've got the parts here. 15K, yep, perfect. That's what I was hoping it was. So what I have here is, yeah, the focus really is a little bit too low, isn't it? Okay, this we have. Now, what are the pinouts on this? I think that was signal.
S is for signal.
Yeah.
And then plus or minus. Is
Plus minus. Yeah. And do you remember what voltage this ran at? Was it 5 volts? I have a feeling that we need to bring up a lab power supply.
I think it did run at 3.3.
Oh yes, that's right, it did too.
I think it did eventually.
All right, so I've got to get the lab power supply up and running. So what I'm going to do is get everything hooked up here,
At
and
Henrik
then...
Ostrov said, lots of buffering frame drops.
Ooh, okay. Let's see. I'm going to... Oops. You can't see me right now, but I am just going to try to hide. I'm going to hide the OBS window because I found that this, when it's trying to render, it does slow things down. And I'll bring this to the foreground, and your regularly scheduled program will resume. Now, I need...
in designing motors in one specific use case is a rotary dial with force feedback for controller input.
Ooh, that's a fun one.
So create a little bit of like the old stepper motor effect, isn't it? If you short the wires out on a NEMA 17, then it becomes a brake instead of a motion.
Yeah, so you can give it some tactile response. Yeah, I've seen that done a few times.
We do that one and short that out and just to work out which pairs of wires go where.
Okay, so the way this Hall effect sensor works is we need to provide it with power, and what I've got on the lab power supply at the moment is 5 volts. It runs from a range of, I think it was about 3 volts or 3.1 volts to 7 volts when I checked the data sheet on that. And then we want to be able to measure the output. But this has an open collector output, which means that normally the output is high impedance, but it pulls to ground when it wants to assert a pulse. So what we do is take, I'm probably going to need to do some, oh no, this should work. I think I can manage this. So what I need to do is have a pull up, no, that's pull down. I need to add it to the 5 volt input.
Yep, I'm just going to go to the chat here for a second.
Yep.
Grant says there are a few articles on the Arduino forum and YouTube on building a hot wire anemometer. How one works would probably be interesting for electrical apprentices. Probably not. Yeah, they're interested in certain things until they're not interested. As we know, our attention span these days is really, really short. And I've noted also, Grant, that your son is a 4th year apprentice at Box Hill. So it's a great campus. We've got some really nice gear there. And nice teachers too. I do get a good Yelp review generally. That's a nice thing. So yeah, look, it's probably one of the better campuses, I think. We do quite a lot of electrical apprentices at the campus, not advertising, but yeah, we do have a fairly high standard for our students, which is good. I mean, all TAFEs do, but we're proud of ours. That's probably the message. Okay, Mr. Out the Box says, I've got one OG. What's an OG? I'm holding
Original Gangster.
Original Gangster, okay. Now I know what the meaning of that is. Okay. Old guy, I thought. Those cheap Wi-Fi units can be plugged directly and routed via Wi-Fi, so when the internet slows, you can plug it in for boost.
Gav, you were a good bloke.
That's nice. Who said that? Crispian.
How the heck did word get on the street about that?
Oh, gee, don't leave word.
Stand by for the smoke test,
Yeah,
says Mr. White. Yes.
Yeah, this is a very dodgy sort of setup that I'm doing here.
I did say I always buy 2 of things, right? Yeah, good.
Yeah.
There's 2 more in the car, just in case.
Okay.
So back to you, John.
All right.
Have you noticed we haven't had too many squirrels
come
today?
on.
Have you noticed that? Just quietly. Quite proud of this squirrel count today. Very low.
Very low. Okay. Now, that is a super dodgy setup. I'm going to turn on the power. Nothing went bang. That's a start.
Can we put that in the what can possibly go wrong department?
Yes.
Okay, good.
So this sensor has an LED on it. I'm just going to try putting this near a magnet. I'm going to use a different magnet. Grab a random magnet that I happen to have nearby. And you can see that as I move the magnet near it, the LED turns on. So that is how...
Jono trying to bodge is funny.
Trying to bodge.
It's even funnier in person. Always buy 2 when you're not sure. If you blow something up, have another one to use when you decide I should have done it the other way around. Yes, absolutely.
And
I think
it is on a very slow time base.
I know, yeah. Hendrik has something to say here when it eventually gets its act together.
Oh, okay.
Unless your dodgy things
It's
work
work
mostly.
mostly.
Is it? Doggy things.
Doggy things.
Doggy things. I don't know you had a dog, John, but that's okay.
I don't at the moment.
Dodgy nut. Could that be dodgy? Could be.
Could be. It is dodgy.
He's got a brother.
Yeah. That just popped off. All right, what I'm going to do is grab myself a big hunk of blue tack.
We've had a wolf comment, Patricia.
And
When's the barbecue, John? Is it
barbecue
2
is
weeks
July.
away?
Yeah, July 12, I believe, is the next one.
Okay,
Something like that.
Not next weekend, the weekend after.
Yeah.
Okay, cool.
Now, okay, part of my lead has dropped off here, but first step is, on screen you can see the LED. If I spin this fan, see how the LED turns on and off as it goes around different parts of the
At John
magnet.
Dashwood said, mostly.
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 Mostly,
Okay,
mostly harmless.
so now I'm going to leave that alone.
July 12th. Yep,
I'm
correct.
going to reconnect the ground to the oscilloscope, and then we are going to bring it up on screen. So if we now switch to this view, now it's the Gav Show again.
Hey,
So what you're
Good.
looking at there, what you're looking at there is the live
Not mu-
output
not
of
much
the
work there.
oscilloscope. And if I slowly turn the fan, it'll get to a point where you will see the trace change. So you can see it's gone high and low and high and low.
about 5 volts, is it?
Yes, I've got it set to 5 volts. So now I'm going to try sitting this up on its side. No, actually I'm not going to. That seems fraught with peril. I'm just going to angle it up, and then we'll blow through it. This is going to be loud for a moment, but then we should see the PWM. Oh, I've got to turn it on. It helps if I turn the fan on. Okay, and I'll put it into a low speed mode. So the fan is now spinning, and look at that. As the speed of the fan increases, the frequency also increases. I'll move the blower closer, so the fan is spinning faster, and you can see that the PWM is still 50% duty cycle, but the frequency is increasing. And then I'll move the fan further away. And when I say fan, I mean the blower away from the fan. And you can see that the frequency decrease. I'll move it away and I'll turn it off
Doesn't take
entirely.
much to dry John's hair. No, it doesn't.
No,
That's
it
true.
doesn't.
No, not at all.
It dries very quickly. And it stopped. So,
Eventually.
yeah. So, yeah, it is working. We've
Two
got
things happened.
yes.
I saw John do it with my eyes, so it did actually happen.
It was
And
real.
2, nobody got hurt or injured. So
Yeah.
that's good.
So far, yeah.
So far.
Yeah. There are sharp multimeter probes here. I could stab myself with one of those.
Did you fill out the JSA before? No. Okay.
No.
What's the max frequency you van get out of it? Success.
Success. Yeah.
Success. I'll take the win any day.
Henry said, what's the max frequency you can get out of it? More frames dropping. Oh no, damn. Okay, so the Dodge mostly comes out at night. Mostly. I know that there are people who get that reference.
I thought you were,
Thanks, News.
I thought you were a BMW man. Okay. Right, so where are we at?
Now, where we're at. Okay, so we had Henrik ask what's the max frequency. I'm going to, let's mess around with this a little bit. Measure, what measurement options do we have? Vmax width, I want, where are we? V-base, VPP, V-top, no, horizontal, no, I want, yes, horizontal. Frequency, that's what I want. Let's measure frequency, and that'll do. We don't need anything except frequency. Other, okay, I'm going to, you can probably just see frequency there. It's showing nothing at the moment because there is no signal coming in, but I'm going to lift the fan very carefully, oops, and
Drop it very carefully.
nobody heard anything then.
That never happened.
And then I'm going to start blowing through it again. And you can see on the right hand side we've got the frequency number. So it's showing about 7 hertz, 8 hertz, heading up towards 9 hertz. If I move it a bit closer, 10 hertz going up, the fan is spinning faster and faster at 13 hertz. And if I move it away, let it slow down, the frequency drops again. Now that is with the blower very close. So knowing this number is very useful when it comes to the next stage of doing software to deal with this.
Oh, it hurts.
Oh, it hurts.
Yes.
Because we're looking at a maximum somewhere around 12 hertz of square wave when the fan is being blown quite quickly, like about as quickly as you would expect to see it ever spinning. So if we are measuring up to say 20 hertz, if we expect to see up to 20 hertz at maximum airflow, that probably...
Because you've got your fan vents in and out, they're going to be different speeds and different pressures, so the propeller's going to turn at different rates.
Yeah, yeah, and the different parts of the air conditioner have different grate designs. So in some cases, you might be able to run all of the air through the fan. In others, the fan is going to be across just part of the vent. But the blower on maximum? Oh, okay. All right.
All right, just
all right, let's do it.
Okay.
Let's do it.
What harm can possibly come from this?
Yeah, what can go wrong?
What can go
Here we
wrong?
go. I'm going to
It's a long list. Are you wondering what? Might want to try the other way too, John, if we can do it from the front?
blow it from the front.
Yeah, because then you're not getting the sensor being part of the airflow, if you know what I'm trying to say.
Yeah, okay. I'm going to...
I would normally be doing it from that side.
From this side. Okay,
Yeah.
let's see how much we can... Let's see what frequency we can get it up to. Well, about 130 hertz.
My air conditioner fan won't go that fast. 130 hertz.
Yeah, that was hiking.
Yeah. And the front fell off. Yeah.
Yeah, the front fell off.
Yeah. Does that happen? Well, no, not normally. Yeah.
No.
Clark and Dorr. We'll quote a Clark and Dorr sketch just for fun. The front fell off.
All right.
Regularly comes up at the office.
Waiting for the wastegate sound, says Michael. Yeah. The
Boom,
turbo
boom, boom,
blow off.
Yeah. Okay, so we've done maximum speed. It's good to see the sensor can handle it. It is good to see. Yes. A wave hit it. Yes, the wave hit it, and the front did fall off. Very good. That's actually somebody does know the quote anyway. We'll have to work that one out for the guys who don't know. That's probably a typically Australian thing, isn't it?
I think it would be very much an Australian thing. Yeah.
So, what else have we got in the box of tricks? Felix the cat?
Okay.
In your bag of tricks? What have you got?
Let's have a look.
Not pushing John, just asking.
Switch to overhead again.
No, the front hasn't fallen off yet, Pete. No.
No.
So that's going to give us something we can put in front of the fan and get the speed of rotation of the fan blade, which will help us calculate the airflow in meters per second, hopefully, on the return. Oh, somebody's quoted the YouTube channel. Excellent. For anyone who hasn't seen it, there's the front fell off.
Okay.
So that'll help us. So for the students, we ask them to use some maths, in our case, and work out the size of the entire grid. And there's a thing you can put like a box or like a big sock across the front, but like it's a thing that focuses the air in. Like you would put it on your plastic box here, you drill it the size of your fan, and then you stick that over the whole vent and measure the air.
Okay.
And then you work out the area of that as opposed to the area here. And John, I know I'm doing this off screen, but so yeah, there's a way we get the guys to measure that. And I think your Kogan, have you got a Kogan one?
I do, yes.
Okay. And your Kogan one has different size vents for the in and out on the front of your window mounted one, I believe.
Yes. Okay, so what we have here is a Wemos D1 Mini connected to a couple of things. There is an OLED screen here, so it's an I2C screen, and there is also a sensor. What is this sensor package?
That's the AHD
Yes,
and the DHT in
HT20.
one. So that was meant to be my indoor sensor or my sensor for the purpose of displaying and measuring the temperature inside. That would be one of the sensors on the inside, John.
Okay.
Or it could be the outside sensor, depends on where you wanted to mount it.
A BMP 280. Yep.
Yep,
Okay.
So one does humidity, air pressure, 280, yeah.
And this particular thing, which is still in the bag, is an SHT30 sensor. This is a shield specifically for a D1 Mini, and that gives it temperature, humidity, and I think does the SHT30 also give you barometric pressure? I can't remember
think
what
it does.
stats
It's
it
one.
has.
Yeah, it's one of. Basically, I was just.
I have used those before, but it's been a while, and there are so many different sensors. I can't remember what each one
my
does.
initial one was, being Claude, was like, which sensor could I use? We started with a DHT11 or a DHT22 because I thought I had one of those. Then it moved to a BMP 280, and then it moved to a combination sensor, which it recommended that one you've got there.
This one?
The one on
The one that's on
that one
here.
there, yeah.
Yes.
And now I'll put an LCD on there, and just to see if it would actually work, so I could get some sort of indication. And as far as I got was, because of two reasons. One, I don't know if I put the pins when I soldered them into that on the right side or the correct side, because I think if you put the sensor below it, is the heat of the mechanism going to affect it?
Okay.
That was one of the things I'd considered.
Yes.
So the heat of the ESP chip and the electronics might warm up the board if it's too close.
I expect it would, yes.
Yep, so I didn't want to necessarily do that. So I thought, okay, I'll start with that as a starting point. And then, so that is one of the sensors. So you could satellite that away. That's the reason I bought that rather than the sensor shield, was to satellite it away from the electronics.
Yes,
So it was
keep that
further away.
isolated so
Keep
the
it
sensor is
isolated.
off on its own.
Yep. And I added one more feature with the second sensor on that one, which was good. And then I looked up the other sensor we were looking at. That's the same as the one we've got there. And then I went shopping and looked at SHT. I looked at the sling cyclometer thing we had at work. And I thought, what looks like that? And Claude came up and said I'd recommend this SHT30. There's a 30,
that
a
one?
31, a 40.
Yeah, this one's an SHT30.
Yeah,
yes.
and so is those big ones.
Oh,
They're the
so
same.
these are also the SHT30.
Yeah, but they're in a more
just
ruggedised outdoor
in a different
case.
enclosure.
Yep.
So what you can do,
You
for
can open it.
example, is you could drill a hole in an enclosure, pass the cable through, and do this up so that the sensor in the enclosure is going into the volume of whatever it is you're wanting to sense, and then the cable can pass through and go to the micro located somewhere nearby.
Yeah, Hendrick's saying the shield version is bad. He's used them in the ESP generated heat, which made the temperature measurement wrong.
Yeah.
So that's what I suspect was going to happen. So it was my first purchase, Hendrick, to be honest. It was one of those AliExpress momentary purchases. It recommended that. I bought one for like $2 and went, we'll wait 5 days and see what turns up. And then while I was thinking, Claude again, in my long and arduous journey through Claude, came up and said, well, have you thought about this one for outdoors? And I went, no, but I'll have a look. So that one has got a fixed address, I believe, John.
This one.
So I think you can actually take the top off it as well.
Oh, okay.
I mean, you can, if you,
Unscrew. Oh,
Yep,
yes, I
you
see.
You can get
So
to
that
the
comes off.
internal electronics, but there's no...
Oh, that's actually really neat. What they've done is they've just used a standard, like a grommet type system there, and this screws onto the top of it.
Yep.
Yeah.
And the sensor's a little tiny dot, I think you'll find. It's really hard to see it. It's all encapsulated and weatherproofed.
Oh, it's exposed there. Yes.
Yeah, it's just one, that little tiny spot where it's exposed. I don't know if John can show that.
This
on
is
the
interesting.
screen.
Okay, I'm going to bring this up on the. Oh, yeah, I'm going to bring this up on the microscope because this is interesting to see.
I figured you'd like that.
So this is the contents of that sensor. You can see that the cable comes in. And
It is called a cable gland. You are correct.
Yeah,
Andrew.
cable gland, and then
It's called cable gland.
That's it.
yes, and then the electronics is all encapsulated except for this little spot. Let's see if I can zoom in on this a bit and get the focus.
Now you're just
in on
showing
it.
off, aren't you, John? Okay, got
Yeah,
it. Yeah, because you can.
because I can.
Yeah.
So that is the sensor, which is very
I
interesting.
do like it.
It's interesting that they've done the way they've done this conformal coating, and it would take a fair bit of work actually to
get it in
not coat that sensor. I wonder how they did that. Whether it doesn't look like they've put tape around over it and then removed it. Just judging by the edges of where the conformal coating comes to. That is.
Is that like a fried Mars bar thing? Is
I'm a little bit of a.
it? You achieve something without destroying it in the process.
Yeah. How did they keep that
Still on trousers,
uncovered?
yeah.
It because of the. Like if I'm gonna get a pointer. It's a little hard to see on the camera. I can see it
Don't you
more
go breaking
clearly.
my $5 part, okay?
I won't. But if you look at the top edge here,
Yep.
where the conformal coating overlaps with the body of the sensor, it's irregular. So I don't think that there was a tape square stuck on and then the tape removed. I think it's like it was brushed up to that edge and slightly overlapping, almost like this was done by hand. But that would be quite a task. There's a sharp edge along here. Anyway, that was just a
Hand
little-
brush and a lot of patience, I've been
yeah.
advised.
That's just a
Hand brush and a lot of patience.
yes.
A very steady hand.
And someone who has done them thousands of times before, so they can do this in about 3 seconds and get it right every time.
I wonder what the failure rate would be on that.
Yeah. Interesting. Yeah, to give you a sense of scale, that's just where it is. The sensor is on that face there, exposed on the top. All right, so cable gland and the cover, so that goes over the top. Push that sensor right up into it, and I'll do the back part of the cable gland up
Yeah,
again.
I think that's an insect shield or something on the outside. Stop
Onto the outside.
small animals getting in there.
Yes. Okay.
And dust, I guess, would be probably exhibited.
All right.
There are steel versions of it as well for more industrial environments.
Oh yeah, where it might be knocked around.
Otherwise,
Because otherwise there wouldn't be a bubble.
yes, says Hendrik. Yeah.
Otherwise, it wouldn't be a bubble.
So we've got a couple of
All
different
right.
sensors, and then tied you. And then there's the third one, which is this
Oh, this one.
indoor version or smaller version. So I figured that my mind was going to the one on the long cable could be on the outside sensor, on the outside compressor unit on a split system, and the inside one could be using the one on the short lead because they're the same sensor type and the same model number. So they should be comparatively similar,
Yes.
being I2C devices, but they do have the same address, and I think they're both fixed. You can't adjust them because they're conformally
Yes.
coded.
Yes.
So I think that's
So
where
that
that
is the
multiplexer comes into it, isn't it?
That's right. So, a little recap of exactly what Gavin is talking about there. When you have multiple devices on an I2C bus, like we have in this case, there are two sensors that are on this breakout board. There is the screen, which has a certain address, and then the main microcontroller, which is talking to those three devices. Each of those devices needs a different address on the bus, so that when it sends a request for information from one of them, only the correct one responds. And if you have multiple devices if for example, we wanted to put two of these screens on and address them separately, you need to change the address of one of them so that you're not just talking to both of them at the same time. And on devices like this, there are typically jumpers somewhere on here. Somewhere, maybe there is a jumper, sometimes they don't. Oh, this looks like there are some, just down here, there are a couple of resistors that can be moved on the back of this, which would change the address, so you could have multiple screens connected. But some devices do not have modifiable I2C addresses. And then you can only have one of that sensor on the bus. And if you want to have another sensor, you're out of luck. So the way to get around that is you use a multiplexer, which is basically like a switch. And what the multiplexer does is allow you to fan out the I2C bus onto multiple sub-buses or tails, and then you can have identical devices on each of those tails, and then depending on where you set the multiplexer, you're talking to a different target device. So that is what Claude was suggesting to use to get around the problem of talking to multiple sensors that are all fixed on the same I2C bus address. And that is actually exactly how we deal with the I/O modules in Testomatic as well. So the TCA 95, whatever it was, part number, which we used in Testomatic to connect to the different I/O modules, is the same thing that Claude was suggesting to use here to talk to different sensors. So, next steps. Gavin.
Yes.
What is this currently doing anything?
I
Is
think
this
if you
running?
power it up, it'll just show the test display, which I think was what I got Claude to do.
Okay. Is it reading from the sensor?
Not doing
or
any reading
anything?
at the moment, I don't think, no.
Okay.
But you're welcome to program it, John.
Okay.
Absolutely.
So the question here is,
So we have
what is the next?
we
What
can
are
take
we
a
going
few
to be
paths,
doing
can't
next?
we, with this one? Yeah. Now today we came to do the sensing thing
On the fan.
on the fan.
Yep. And
And that would go into an analog input pin, wouldn't it?
or digital.
Or digital input pin?
Yeah. Yeah. So the way that works is that we need. In fact, I'm going to grab a piece of paper.
So I
Right.
bought a battery pack along with me. So I was thinking myself, depending on how well we go today, we could possibly plug the fan sensor into the WeMOS, give it some really super simple code, and just ask it to read an input and display
Display a frequency
a
or
frequency to show us what it is, and then place it in front of your fan of your air conditioner,
yeah.
and get a value for what the fan would be on high speed or low speed, or the compressor outside.
What was the sensor model? Again, the purple one.
The purple one. Purple? Was there a purple one?
Oh, is that the little sensor with the 2-in-1? The shield was that one. I have what? Let me see. I have my magic box over here, which has got some other bits in it. I will get the number for you right now.
Okay. While I'm drawing this little.
And you might hear some
Diagram.
noises. I'm sorry if it's noisy. John's drawing a diagram.
So, actually, that is not correct. We are not going to connect that. We're going to take a resistor to there. We're going to have an output from the fan going there. And that is going to
I'll put
an
that
I/O
back here.
pin.
That's that sensor.
That's out. That's ground. We're not going to be connecting to the fan on the power side.
I'll let you continue with that, John, or I can continue to search.
Well, actually, if we're using the sensor module, then yes, we will connect 3.3 volts through. I've had it running at 5 volts while we've been doing this test because I've just got it connected to a lab power supply and we're reading the signal directly with the scope. We're not using a micro at all right now. But if we're using an MCU, we're going to send 3.3 volts down to the sensor module. We take the output, and then at the moment I've got a 15K pull-up resistor, which is going from the output up to 3.3 volts, well right now 5 volts. And so what happens is that the MCU is going to read a signal, which will be like this, where the frequency is going to be proportional to the speed of rotation of the fan. So what we are going to be measuring is a 3.3 volt range as that turns on and off.
Okay.
Okay.
just the question about the
Get that out
sensor.
of the way. Yes.
There's a SHT30 outside one,
Yeah.
and this other little guy is the same but a smaller package without the leads.
Okay.
And the other one was a BMP280 AHT or something. Combination one. It's on my. I can't drag it up right
Yeah.
at the moment. I can. Can we read it?
Yeah, we can read it on here. It is an AHT20
AHT20.
plus a BMP280.
Yep. Which is, I think, a standard Arduino library for that one as well.
Yeah. Okay.
So
So I think
I've got too many things, haven't I?
I think our goal for today is, let's see if we can achieve this by the end of the stream. I want to be able to take this device out to the air conditioner, which is it's just on the front of the lab. It's only a few meters away, and have
I have a battery pack, so we
you have a
can
battery
run it
pack,
from that.
okay, and have one of these boards reading that frequency and reporting it back. Given that we have 20-ish minutes, this might be a challenge, but let's give it a shot.
What can possibly go wrong? Many things.
Many things. All right, so which board are we going to use? We've got this Fire Beetle.
Yeah, that's a Fire Beetle, just a bigger version of that one. That one's nice because it has a battery capability. So there's a plug-in battery.
Let's use this. Does this one work with the... Oh no, you've got a USB.
I've got a USB pack.
Oh, that makes it
I've got
easy.
a
We
jump
can just
pack,
plug
so
it
it's
into
easy
there.
just to
Yeah.
plug it
Yeah,
in. That
okay.
was a bit, maybe another show, another day.
Yeah, let's give this one a shot. So what we'll do is try to get some code on... Step one is to get some code onto this, which will read from this sensor and give us a number, which just represents the rate of rotation of the fan. Then we can power that off the battery to make it portable. And if we manage to get this far, we can possibly have this connect to Wi-Fi and
John's Wi-Fi, maybe.
broadcast the address, or, well,
Show that. Maybe if we're really lucky. I mean, 20 minutes is a fairly tight
it is very tight.
schedule, but I've worked with worse.
So, pulling all of this off, what we can do is, on that diagram that very crude diagram that I waved around before, this 15K pull-up, which is this resistor right here, that's the one that I was just using when we had it connected to the scope. What we can do is turn on the internal pull-up inside the MCU and not use an external resistor. So all we need to do is have 3 connections from the sensor module to the MCU. It's 3.3 volts, the ground connection, and the signal. And the signal is going to go to an I/O pin with a pull-up.
Now I'm going to grab that MCU for 5 seconds, if you
Sure.
don't mind, John, and I'm going to plug it in to make sure it works.
And while you're doing that, I am going
And I've got a
to
blinky light on it, on my power pack, so okay, it's all good, it's going to work.
I'm going to grab myself out of my tub of Jumpos some cables so that I can plug them together.
This is entirely
I need-
scripted, isn't it?
Yeah, we are. We are professionals.
I'm your wing it man. Let's just wing it. Okay, Hendrik sent something. What did he say here? Sorry, look in Discord. How do we do that, John? Okay.
Look in
let's
Discord.
see.
That's probably
So
beyond our
let me-
capabilities right at this
I'll
second.
be the man who reads stuff. I'll be the
Okay.
production assistant here.
Okay.
Okay, conformal coating looks torn at the top and masked at the bottom, says Mr. Fixit. 4 sensors, air temperature in out on both radiators. Yeah, that is the plan, Steve. One on one side, one on the other, one on the input and one on the return air is
Yes,
my plan.
that is exactly
Hence the
right.
4 fans. Alternatives to a multiplexer is a chip is to have multiple I2C buses.
Yes, that's
Which I-
another idea.
Yeah, now I think this is an ESP8266 based
This one is, yep.
Yeah, and I think the Fire Beetle, if we look in my Claude code, recommended, I said to it, can we go to an ESP Fire Beetle 2, which has multiple I2C buses? And it said, oh, we can do that if you buy that chip, which I've already bought. It's just, I only bought it yesterday, so it's going to be coming from China.
Okay.
The purple one, yes, we've already covered that one. Digital pin with interrupt, counting the falling transitions per second.
Yes.
Yes, is that how we're going? Yep.
That seems
Now, Hendrik, I can't
reasonable.
look at Discord because I don't know how John does that, and he's a bit busy, but we will look it up. To calibrate the approximate speed, airspeed kilometres per hour.
Oh yes, for that we were going to do some calibration with a third-party anemometer.
Yeah, which I will, if we're going to, I can assume you'll be okay for us to come back at some point.
Yeah, we'll see how we go.
See how we go, and maybe calibrate it. Or I'll try and calibrate it at work, one or the other. And Hendrik sent something. Hey to you all from sweaty Denmark. Sweaty?
Sweaty
Oh, they've got
Denmark.
heat at the moment, that's right. Can we have some of yours,
D3.
please? Please, sir, may I have some more? Because we have none. All of ours has gone to the penguins. Yeah. African or European anemometer? European, I think. That's a Monty Python question.
Yes, it is.
Fully laden?
laden?
Or, yes, fully
Yes.
laden or not fully laden?
No, I think it is
I don't
fully
know.
laden. That's just.
I don't know.
Is it African or European swallow? Okay. Stuff. We have stuff connected. The next challenge is going to be code. So we're going to get some code onto this.
Have you had a drink? Do you need a bit of fluidation? Because
Oh,
I hear your
thank
voice
you.
is going.
Yeah.
Just a quick.
I shall.
There's a little bit of darkness getting into your voice, Joe.
Yes, it is
It's
a
got a
little
little bit
dark.
dark. We don't want to do that. There you go.
That's better.
He sounds Pirate
Yeah,
Day.
the good stuff.
Actually, we missed that, haven't we? We missed Pirate Day.
Pirate. Yeah, speak, talk like a pirate.
Back in May, if I remember right. April or May.
Okay, I'm going to
Now, where was
hook
I?
this up, and then let's see what we can do in terms of getting some.
So those playing along
Code
at home,
onto this.
this is the model number.
Oh, there we go.
The chip itself.
And
It's an old one.
it is time now
To break it.
to. Oops. Yeah. Let's. That. Look into talking to LLMs like a caveman to save tokens.
Yes, I've done that at home, Steve. Yeah, caveman mode just gives you back. Yeah, that was on my my Windows-based machine, but my Raspberry Pi ones have definitely got the caveman option and the Claude Mem one as well to remember all of the bits and pieces. It does It does improve your tokens consumption a lot. And the other side project I'm working on, yeah, that definitely does help with that. But this one is on the main screen at home with the triple screen. Mine's a bit different to yours, John. Mine isn't 27 feet wide and 6 foot high. But this is impressive, but yes, scary.
Okay. What's going on in the meantime is I am waiting for Arduino IDE to open. It is slowly opening its things. What I'm thinking of doing in order to save some time here is find something like a frequency counter library that should be able to do this sort of thing just straight off an example. I also need to find the board profile. I have not used an ESP8266. It must be measured in years since I have used one.
OG?
ESP8266.
OG again?
Yeah.
Gangster?
Generic ESP. Do we have a specific one? So this is the Fire Beetle. Let's see if the Fire Beetle has a board profile.
Oh, there we go.
Hendrik!
Again. Oh, where's that dancing when you want it? Code's in your Discord.
Code's in the Discord, okay.
I think Hendrik's been busy while we've been talking.
Yeah. All right, I will open Discord in just a moment. Now, if I open Discord, I may have to, let's see which window it's going to open on. This could be bad. Hopefully it'll open on the window that is not being screen shared. I'd better do this, just in case.
Yeah. And I'm over here,
Yeah.
just for the record, manipulating John.
I am the puppet.
I'm the puppet master. There you go. Oh, I didn't dance.
Chicken Pasta.
Chicken.
Sorry, Chicken Pasta is Henrik's latest Discord
Pasta?
user. Okay. I think the last code helps you a bit. We have a DMOS20, a Copilot. All right, let's see what this session says. Bring this up. Here we go, and I will pop this up on screen. this is what Henrik has just sent me the link to, and I will embiggenify that so that we can all read it together. D1 Mini as a tiny web tachometer is perfect. Of course. Why is it that LLMs are so sycophantic? Oh. Just, it grinds my gears.
What's sycophantic, John?
Oh, sycophantic is when
we
you,
throw that one around.
yeah, it's when you're sucking up.
Ah,
Telling someone
compliant.
Yeah.
Happy to help you.
it is telling someone that they are the smartest person ever. This is the greatest idea that anyone has ever had.
Yep.
Yeah. It's when it says, yeah, this is just touching on it. Using this is perfect. Like, why even have that sentence in there? It's all it's doing
Chews
is
up tokens.
it's pandering to the ego of the person.
Token consumption, mate.
Yeah.
Token consumption.
Yeah.
Yeah.
It's
Caveman mode, John. You've got to look into caveman mode. It's true.
Okay.
Yeah, enter. Do this.
All right. 10K pull up. If it doesn't already have one, I was using 15K, but who cares? It could be anything from about 1K to like 100K would work. 1K would be too strong. Now make it on a rotating part. Yes, so it does that. We've got that. Uses an interrupt on D2 to count pulses. All right. I need to check. So there are limitations on the
Scroll down there to
ESP8266.
code the last one.
Okay. There are limitations on the ESP8266 in terms of which pins can be used for interrupts. The ESP32 is a lot more flexible, but the ESP8266 had some quite severe limitations. So this last bit, is this the bit that we should do? Let's do this.
What can
Let's
possibly
just-
go wrong?
Let's just YOLO it. Come on. Come on. Open and bring it up here. And get rid of that. And
Drop
stick
that
it in. Drop it in.
Yep. So we need to change to a
So we
D1.
need to change that and that.
and swap
and-
chips.
We can use the one that's plugged in.
Can we?
Yeah, we just need to make sure we got the right I/O pin selected.
Yeah.
So, let's have a quick look. What have we got? Whole pin is set to D2, so I need to find D2, and this might vary. Now,
Whoop.
okay, next step, next step.
I'll get out of your way again.
No, that's okay, it's all right. Hang on, I need to cough properly, so I'm going to mute, which is also going to mute Gavin.
Yep. Right, we're back on the
Okay, we are back. Board. Now, board. ESP8266 boards. Which one? What is the closest match for a
I
fire
think
beetle?
There is a library set for that, but that could be longer to get. So
Yeah, it's probably similar to. Where is it? There was the really common one. The one.
Lowland.
Yeah, Lowland. Yeah, it looks a bit like a Lowland. I just
It's
don't
an
know how it's-
ESP12F. So
Yeah, I just don't know how its I/O pins are mapped. So let's go for and maybe Node MCU, ESP12E. That'll I'm going to pick a Node MCU. It looks very similar to a Node MCU. And
actually, I
I'm
have
just-
one of those too, if it helps. It doesn't.
Oh,
It's
okay.
good. Let me have a look in my bag. I told you I bought stuff. I think I had one of those.
And I've got it plugged into D. Which pin do I have it plugged into? I'm going to check that. I might just move it
This
to
one
D2.
says Node MCU on
D2.
it. Would that be easier?
Yeah.
Yeah.
Let's do that.
Okay.
Okay.
The other one's just
So it doesn't
fancy.
have. Oh no, but this doesn't have battery management. Oh no, we don't care.
We don't need that.
Okay, we don't
just
care.
plug it straight in.
Oop. Yeah, we don't need battery management.
That
So
one.
what we're in the process of doing is switching from the Fire Beetle to this, and you'll see that they're very similar boards. They have different pins, like different I/O, but the concept is the same. They're both ESP8266s. They've both got USB on the end. This one's got some power management. Looks like they both use the same USB to serial converter. Without reading it, my guess is CH340G for the USB to serial converter. They look like they're both the same. Yeah, so let's go for the Node MCU, and the pins that I want. Where are the pins I want? D2 is there, so that's the one that I want for my taco input. We've got the G pin there and the 3V pin there. So I want green into G, and the yellow is my power going to the sensor, is going to come off the 3v3 rail. That goes to D2, which is the third one down. Is that it? I think that might be it. And then we stick that in there. Yep, that is still working. You can see the LED flashing. So,
Yep. Oh, sorry. Yep. Somebody said sycophantic. That's probably right.
Yeah.
It sucks up to you.
that's right. That's a good way of putting it. Okay, now back to here. Did I select Node MCU? No, I select. Yeah, I did. Node MCU.
We're vibe soldering today, apparently.
Vibe soldering.
Yep.
Yeah. I'm going to try compiling this and just see if it compiles. And then I'm going to change the Wi-Fi details off screen because I have not yet set up a. One of the things I need to do is set up a public network, which I can use for testing.
Cool.
I know, people keep telling me I need to do it, and I haven't done it. Compiling. Oh, is it seeing the port?
Now, you've done that before, I remember that.
There, that one.
Good.
Yeah, oh, I have done.
You have done that before.
I've doxed myself
Yep.
many times, as is tradition.
And you forgot to attach to the port a couple of times. Yep.
Yeah,
Yep.
done that before.
You're human. It happens.
Okay, so that is flashed. I'm going to move that off the screen. I'm going to update these details.
I'm not even looking, guys. Couldn't tell you. That's a lovely wall you got there, Joe.
All right, so that,
bad.
and then I'm going to do that. What is it? Okay, so this is going to throw up a web page that we should be able to connect to. It's actually remarkably simple code. And uploading, I'm going to bring this back up on screen. I'm just not going to scroll to the top, which is where the Wi-Fi details are. Uploading. Now, does it also output to the serial console? Whole Wi-Fi begin. Does the begin, gives Wi-Fi status. Server on freak. Okay. So it looks like it doesn't output anything except startup to the serial console. But let's open that up. 115,000. And if I press the reset button on it, we should see it attempt to connect to Wi-Fi RST. What's it doing? What's it doing over there? What is it doing?
No, was it 115,200 or was it slower?
No, it's 115,200. Let's clear that. It is 115,200.
Really?
Do I need to turn on any other options? 115,200. We've got flash debug. All that stuff is normal. Erase flash SSL. I don't think there's anything particularly special in there. Node MCU. Yeah.
So we've got somebody living in Canada. What's this? Oh, he's Canadian living in somewhere. I'm just trying to read this one down the bottom.
I'm just going to bring that over so you can see it more easily. Oh,
Where are we?
the of them. I'm Canadian living in. What is that flag? Asking me about Australia versus Canada. What are your thoughts? Just curious.
For immigration. Wow. That could get controversial, I think, to some people. India. Oh, India's cool.
Okay.
Sorry, we just couldn't read the. Sorry about that.
Yep. So, what I need to do is get the IP address that this has.
When I went to the hospital
Connected
last,
as.
I had an English doctor. She was lovely,
If it has.
including the accent. All of them were lovely. So,
Now, somewhere.
what are our thoughts? It's a lovely country. You should come at least to visit. That would be my first thing. It's only a small trip.
Devices. Oh, there we go. Oh, we got its IP. Okay, so what I've just done is I've just pulled up the my Unify. Let's see if we can connect to it. 192. It is, what was it? 128? No, 218.
218.
218.
Keyboard dyslexia.
Yeah. No, memory problems. Ooh, look at this.
No
Hang on.
spinnies. Ooh, I
Let's
like
bring
that.
this up. Okay, so this is the web interface, and now Gavin is going to go and spin it. And look at that! We got numbers.
By God, that's a bargain.
Um,
How on?
press it on with that, and then you pull the trigger, and it'll make a blowy noise. It must be jammed by the sensor or something.
Okay.
Try moving that. Yeah, there's something jamming it.
Yeah, it is. I can feel it mechanically. All right, I'll just turn it off. Let me just check. It's possibly. Oh yeah, it's right. Sensor's right up against them. Come out here, you. Let me see if I can get this in a better position. We really should reverse these connectors over. We talked about that last time, didn't we?
We did.
Putting this, was it perpendicular or was it?
Yeah, I think that's.
Is that better?
Yeah, we've got a frequency coming through.
Cool.
All right. 10 hertz. Ready?
Well, seeing as we're in a good mood and you've gone Wi-Fi.
We're getting numbers.
Well, now let me. Is there an air conditioner running over there?
There is an air conditioner running over there.
I will just disconnect.
All right, so this is going to drop out right now.
We've got to thank Hendrik for that.
At
That's
this
good.
moment, what Gav is doing is disconnecting the micro
Yeah, he's trying to reconnect a new one with his old tired eyes.
and connecting
Power to
a battery pack to it
Jump
so that
pack.
it can go portable.
Nerd brag. Did nothing all week.
Haha, that's a great brag.
Is that powered up?
I think so. It should be. Yeah, it is. Yep.
Yeah, 'cause
I
I
saw
just-
the LED flash
I just
then
saw
when
that
you put it
flash.
on the fan. And let's.
I'm just worried about the.
Yeah, that looks
free
good.
spinning.
Yep, it's free spinning. Oh,
Okay.
and we've got a frequency coming up.
Right, so let's go put this
So-
in front of the air conditioner.
Gavin is going to walk over there. I'm going to switch to this view.
Oh, and I'm going
we
to
are
keep an eye
going-
on this.
And unfortunately, we don't have a camera over there. Oh, what we can do. I know what I can do. I know what I can do. I can go to...
There we are, John. Flashy lights.
Flashy lights. Look at this. Hang on. Not there. I'm going to switch to a different camera. I'm going to switch to this camera.
Oh.
Okay. Here we go. Look. There is me in the background with some lagging.
Oh, I can't dance from here.
Who is that? I've got stuff
that's
all over the
the-
screen. I can't tell what's going on. Oh, that was Henrik again.
So this is the intake air for those who are playing along at home.
Yeah, so
That's the air being sucked into the unit to compress.
you can see Gav off on the side there, holding the device up against the vent on the air conditioner, and you can see the frequency coming out here, updating.
And then the other one is this one. This goes the
Ah,
other
okay.
way.
Last $, new updated code in Discord. Try as well. So this is from Henrik, who.
Yeah, where's the flashy light there?
Okay, this one. Updated.
That's the other one.
Updated
Let me see if I
code.
get this right.
So Gav is just trying to reach the other vent, the outlet side. He was. That first one was measuring the inlet side. Now trying to measure the outlet side. The frequency is jumping around all over the place.
Oh, there we go.
Okay. Let's try. So
What's that
this-
one?
That is not reading anything at the moment.
Oh, I'm trying to keep it there.
Maybe something's fallen off. Because it's not picking up any pulses from the sensor. Is the sensor near the magnet?
So now the other one's stopped. Yeah.
Yeah.
And then this one
Try
stopped.
rolling. No, we're not getting anything at all.
Should we now?
Look, Discord again. Yes, Henrik, I'm getting there. I'm getting there. I actually have it open. I've got this open, but I was Oh, another one. Okay, last one, and the bottom code. Okay. The bottom code.
Okay.
All right. Gavin is going to come back to.
And I
over
can get
here.
a third reading if you want to, from outside.
Not yet, not yet. We're going to
Okay,
do
you
some
want-
code updates.
Oh, okay, quick. We had an update.
We got an update. So
Just-
this is an update from Henrik.
International
So
Rescue.
what does what does he say? So we've got details there. What's the change?
What is the
light
change?
frequency.
Oh, the button fell off. Hang on, the front fell off. Where did we go, John?
All right,
Pin fell off.
pin fell off. That's all right. I can figure that out.
Yep.
That goes to D2, which is that one there. That might be why we weren't getting pulses coming off it for the last little bit.
Nice little bit.
So, what is the difference? What change has happened on here? So we've got freak there. Automatically updates every 200 milliseconds, no refresh needed. Yeah, well, wasn't the last one updating? Okay, I don't know what the difference is, Henrik, but I'm going to try this one. Copy, and I'm going to stick this into here. Close that. I'm going to do all of that and delete it. Paste that in there, and then I'm going to change this, but I am going to take it off
Go hide
screen.
it
I'm going to
quickly.
go badoink, and
Nope.
you can stare
That's a lovely wall, John.
at Gavin's the back of Gavin's head while I put this in.
Oh, that's it. Isolation switch with 3-phase. That way, don't look at your password.
Okay,
All
that's
safe?
all right. You
We're
can
safe now?
you can look back now.
We can go
It's
back.
safe. It's safe.
So,
So now I'm going to compile and
John,
upload
1,
this
2,
one.
3. That's too obvious.
I know. Yeah.
look at
My
that.
my
Where did the hair
password
go?
is
It's gone.
PASSWORD.
1.
1 hash. Okay, uploading,
Right.
and then this.
We've got to come up
It
with a
should come
better way.
back up on the same IP.
We need to find a better way of using better super glue. That's better.
Yeah, it needs like a little 3D printed bracket or something to hold the sensor on the back of the fan.
Yep. I guess that's my job.
Cable tie is here. So cable tie
That's
can
better.
do his job of holding the sensor there indefinitely. Done uploading. Okay, I'm going to open the serial console just to see what happens.
And the fan came back on too.
Can you press the reset button on here? Oh, that came off. Because I wanted to see what's
Was
coming
it
up on
the
the.
D2?
What? I don't understand why
Third
it
pin,
is
right?
not outputting on the serial console. But I also have not even looked into it at all.
Oh, this D2
There's
keeps coming off.
probably serial begin. If we did something like
Where's-
delay 500, it's probably just that the serial port had not yet come up. So let's give that a shot. We'll bring up because all it does is output the. Or does it? It doesn't actually say anything. So all we're seeing is
We're not getting a return.
the startup information, which is at some weird frequency, 26,000 something bits per second. The debug boot thing on the
Have
ESP8266.
you got any more near this funny blue tack stuff?
Any more blue tack?
Yeah.
Yeah, there is more. Oh, there's some more blue tack there.
Oh, that'll do.
Yep.
Yep. I'll just try and hold pin D2 on again because he keeps.
Done uploading. Yeah. I'm going to press the reset button.
Yep.
Yeah, it's just outputting the boot garbage. So there's nothing actually useful coming up in the serial console. But we should now have, yeah, there we go. We have data coming up
Some
and it is
pulses.
updating much more frequently. So this must be the change. It's doing it every 200 milliseconds now instead of whatever it was before.
Yep, I've just got to get a good.
So what we can do is
Yeah, that's much better.
unplug. Okay, so we'll unplug that from the computer.
Yep,
And Gav
re-energise.
right now is plugging it back into
The right
his
way.
battery pack.
Yep.
And now that whole assembly
Fingers crossed.
can be taken.
Flashy lighty work now.
Yeah. If I
More
go back to
blue
here.
Yep.
Henrik!
Oh, I can't dance and walk, Hendrik. I'm good, ain't that good? Right.
Last link. I think it,
Is that giving numbers?
yes, it is. It's giving numbers.
So that's the
It's too
the
late,
intake.
Henrik. We've already flashed it with the other one. I'll get back to it in just a second. I'm trying to find where is the window for Rio Link? There it is. Okay, so there is Gav. This is live. This is Gav Cam. As he's holding the fan up against the vent of the air conditioner.
Yeah, that's the intake. So that's sucking the air in from the inside.
Yep, and we can see that it's jumping around.
Yep, and the
the
hot
code
air-
that's doing this is only working in very large increments, like
And
5
how many
hertz
numbers do we
increments.
get, John?
It's jumping between 10 and 15 hertz.
Okay, cool. And I'll just move it around a little bit like
So-
a doctor does.
So whatever the code is doing some averaging out here, and it probably needs
Yep.
to give a fine
And then I'll
range
move over to
output.
this one,
Yep. So this is over the outlet
which
side.
goes whiz and much faster.
Yeah, now it's saying 60 to 65 hertz. So it is ripping around. The last one is much better. Okay. Okay, I'm going to have a look at this. This is, scroll to the bottom. Ooh, yeah, what this gives you. What does this one do? Serial begin, attach, interrupt. What's the difference between this one? So handle frequency, handle route. What's the difference between this one and the one that we have just been doing? These links that you're sending, Henrik, are all the same link. It's all to the same page.
Yep.
So,
Can I take a third reading?
yes. Okay, Gav has just gone for a walk outside. Hanging off the outside of the air conditioner. We're seeing 5 hertz. You can probably hear him. I can't hear Gav right now, but he's still got a radio mic, so you can. If he's saying anything, you might be able to hear it. I can't. Alright, so that one is jumping around between 0 and 5 hertz. While Gav is doing that, up to 25 hertz there. I'm going to take this, which is the most
Don't know if the blue
recent
tack's
code
working.
that Henrik has pushed up. Oh, here he comes. Gav is coming back in.
Yep.
I'm going to grab the most recent code that Henrik has pushed up.
The blue tack failed in the cold.
Oh,
Did we get some numbers?
I would fail in the cold. Yes, we did.
It
We
is
were
colder
getting-
out there.
We were getting around 20 to 25 hertz on the outside one when you went out there.
Went out there. Okay, that's because there's 2 of them out there.
Henrik has just sent us another updated bit of code, so I'm going to jump to the
As he
overhead
does,
view.
and we love him for it.
Yeah. And I'm going to update this and push this to the micro as well.
As I plug it in.
Yep.
So I think did we beat the 20-minute limit?
It touched 30, says Crispian.
Which button? When you're ready.
Okay. Stop. Stop what? Look in Discord. What? Another one?
Another one.
Oh, Henrik.
You smashed them out.
It's the same chat each time that you're linking to. So I assume that it is just adding more on the bottom. The one that I've just loaded is the bottom one in that chat. So I think
His
this is the
profile
most
works
recent.
much better than mine. He's asking the right
Real-time auto updating web. Yeah, okay. Look in Facebook. What?
question. Hey, what?
Where are you sending us, Henrik? Now. Yeah, can you spin it, Gav? And we'll see if we get a number coming
Yep,
up.
I was
Okay.
just-
We do get a number coming up. But it is only working in 5 hertz increments, which is a little odd. That is a little odd. So how is it doing this calculation? Pulse frequency is that by that last calc. I've got to be careful where I scroll here because the password and everything is up there.
Secret file.
Yes. So let's have a look in the code here. we have this interrupt that is being triggered off D2. We've got the web page which is doing the update. It's just updating that based on the value that comes back there. So I'm going to skip over that. What I'm looking for here, the interesting bit, is here. So handle frequency, we've got a buffer, string to float. From that, this looks a little odd to me. This is slightly baffling. I'm not quite sure why it's doing it this way. So we're attaching the interrupt to D2. We've got it on the falling edge, which is fine, doesn't matter. We are calling Hall ISR, which is where? Am I misunderstanding this? No. Hall ISR, house count plus plus. What's going on, Henrik?
Last dollar final code. All right.
Okay, another update. Henrik, thank you.
Yep.
At Grandma's it said, 5 Hz updates make sense because it does refresh every 200 mli seconds.
There you go. You got your dance, Hendrik. Just to make sure.
Yes, Grant says 5 Hertz makes sense because it updates every 200 milliseconds.
So make it shorter.
Yes. Yeah, I think we can get around that though.
Faster, and therefore it would be.
Yeah, it's doing the calculations. Okay, what you could do. Oh yeah, you could have a rolling buffer. There are ways to solve this, but I'm not going to get into it right now. So, only makes sense if it's doing something wrong, says Cable Tie. Yeah. All right, I'm going to look at Henrik's latest code.
Your phone's going all crazy, but that's
My
okay.
phone's going all crazy.
It's
Okay,
beep, 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 beep.
I'm going to open Facebook because it seems like that is where
It's the new Copilot.
Henrik is sending me
The
stuff.
new Discord.
Here we go. Didn't update the chat in Copilot. Oh, okay. I see what's going on. So what's happened is Henrik has been sending me links to the Copilot chat, but it hasn't been updating. It's all the same link to the same session. So what he's done is, I'm in the process of copying an entire sketch out of a Facebook message. So I'm going to do new, and I'm just waiting for Arduino to finally open a window. Okay, there we go. Let's stick the new code in here. Here we go. Yeah. This is I'm gonna have to change this.
Sneak that away again. I'll go look at the wall again.
No, that's right. Yeah, you don't need to do that. So I'm just doing a quick review of what we've got here. So we've got min, max, average.
It's a lovely wall.
We've got this, which is okay. So we're doing a JSON payload, which is being parsed by it's being used by the JavaScript. Funny about that. And updating the values on the web page. So we've got the interrupt there. But the bit that interests me is this is changing the way it's doing the frequency counting. Okay, this should get us.
Love your work, Hendrik.
Yeah, thanks,
Love
Henrik. Very
Love your
nice.
work, mate.
All right, so I'm going to switch away from that screen while I update this.
Are you any good with blue tack?
Blue tack.
Hendrik, is he any good with blue tack? He's
Hendrik.
pretty good with code.
Yeah.
I think I've got the blue tack bit figured out. Just more blue tack.
Is the micro plugged in to USB at the moment?
Yes.
It is. Okay.
Yep.
I'm going to do an upload.
Indeed it is.
Very good. So we are currently uploading Henrik's latest code to the H266, and this should give us more information on the screen. Once it updates, we should see this change. In fact, I'm going to need to reload that page because it is going to, yes, update website as well. Yep. It needs to not just be updating the data coming from it. I need to, come on, refresh, update.
I think we're onto something here, John. I do believe
But
this
why
will
is
work.
that? So update using, did that upload or did it just compile? Oh, okay, no, it failed to upload. So
Oh,
it's-
did I push a button or am I spinning around or something?
No, has it found the port? Yep, okay, I'm just going to try uploading again.
Maybe it didn't like the spinning pin.
I wonder if it was busy because the interrupt was firing, so that was stopping it from dealing.
So first we were spinning and then we didn't, and then I did, and that stopped it. Yeah, okay, I'll go with that.
Upload, come on, you can do it. Oh, maybe we just have a dodgy connection on the USB cable. Oh, now the serial also shows you the web address. Okay, on startup.
Oh, beautiful.
Nice, thanks Henrik. Yeah, this is failing to upload, so
What do I need
just
to do?
try unplugging that USB cable, plug it back in, and we'll see if we can. Port is not there. That's interesting. I'm going to unplug from the hub, plug it back in. We've lost our board.
Now, hang on, what pin was I on here? Let me see, did I? No?
So ground 3v3. Yeah, let's see if the
You have to do a boot pin or something on this?
yeah, is that a boot? That'll be the boot button, I think.
Yeah,
So we'll do
on the
that.
left.
Reset that. Keep holding that. Let it go. And
This
then
is
if I
very
do,
old school, isn't it?
it is
Okay.
very old school. Yeah, the port is gone. Okay, I'm going to try plugging this into my.
At cable team said, whoops, we blew up the controller.
Yeah.
Could have.
I'm going to
I hope
try
not.
plugging this in. We'll need to move it over this way by about
Come
another
your way.
10 centimetres. There we go.
How's a half a metre sound?
Perfect. Plug it in there. Now let's see if we've got a port. Yes, we do have a port again.
Okay.
Yay, let's upload.
Didn't like the look of him.
No, come on, do it. And of course, because you're Arduino, you've got to compile again, even though not a single byte has changed.
You know.
I have already gone to lunch, Sir Stephen.
Writing. That's a
Writing,
sign.
right, yeah,
That's a
yeah,
good
yeah,
thing.
that's good. So let's see what happens up here once it finishes. We should also, well, yeah, I don't have a serial console open, so we can't see the boot message, but it'll come back up on the same IP because the
Reservation's been hold.
DHCP server will assign it to the same
hard
based
reset.
on the Mac. Yeah, resetting. Let's see if we get. There we go.
Oh my
Current
gosh.
min max average, and then
I'm gonna
give
just
it a spin and see what happens. Ooh, here we go. Min min is always going to be 0, predictably.
Okay,
Max
so
10,
shall
yeah,
I go
average.
walking?
Yes.
I'll go walking.
I'm interested to know what period this average is over. I could look in the code and find out, but I could also just
Got to find the right side here.
not
Right.
ask that question.
We're back online, I hope. Oh,
We are.
I'm trying to find the pins again. But
Okay, I'm going to close
that's blinking again.
that one. Don't save. And we got values. Max 61 hertz. Okay.
I'm getting some numbers.
Okay.
Right, the back of my
What
head.
What is average frequency being taken from? No. Okay. Now, Gab is up there.
There we go.
Current 9 hertz, 10 hertz, 11 hertz, average 11.17. So this must be averaging across not the time since startup. It must be like a rolling window. I haven't got as far as checking in the code how it's handling that averaging. Where are we? Average. Oh, okay. So average frequency is average freq time, average count minus 1 plus frequency divided by average count. So there must be a definition of average count, and where is average count?
Now I'm interested to know, John, if I
Yeah.
turn this around the other way,
If we get a reading from it,
get a different reading or close reading.
so we're now getting 9 hertz, 11 hertz, 10. So I think it's sitting at around the same number.
Yep. I'm
So-
just checking to find out if it makes any difference. Depends on which way the propeller blade
Yeah,
is
yeah. It looks like the
facing.
fan.
And then over here is Mr. Speedy Boots.
Ooh, I can hear it spinning. 70 hertz, 73, 74, 73, 74. Yeah, it stabilized at around that frequency. So that is giving us the air coming out of the vent.
So that one really flies.
Mm.
And they're out in the cold.
Don't get tangled. Yeah, it's heading out to the outside part of the air conditioner. 2 hertz. It's not reading very much right now. 3 hertz. Okay, so I'm just going to do a quick check in the code for the average. Where is it? Average count. Where is average count being defined? Yeah. Come on. What's going on with my keyboard? The right-hand side of my keyboard is not.
So that's the
responding
air
properly.
blowing out of the compressor outside.
Okay.
And this is the air being drawn into the
Drawn in,
compressor
so we can
outside.
see 16, 20 hertz, 22, it's going up, 23, 25 hertz. Okay, so that's 26, 25, it's stabilizing it around that. Cable tie said,
Cable T said, is this 1 pulse per reverend, i.e. the readings are actually reverends per second?
no, they are not. I think it is 3 pulses per revolution. When I'm not absolutely certain of that, we can check that now, because when we were manually turning the fan, it was giving us more than 1 pulse per rotation. Crispian says, aren't there 2 magnets? Yeah, it could be 2. I was just vaguely eyeballing. I didn't mark it. But we can actually resolve that right now, because what we can do is we can use a marker pen or something and put a mark on
Have
it.
you got a white one? Just out of it.
What do I have?
I just think
a
I
white mark on it. I don't think I do.
What about like a white mark remover? Something we can
That you can take off afterwards.
white out stuff.
Oh, okay. No, that's all right. We'll be able to see it.
Yeah.
So all I wanted to do
Yep. Conversation was work out how many magnet poles there are.
yeah,
Yeah.
precisely. So you can see.
Figure out and look in there.
Well, you can see that there is the sensor there is tripped, and if all right, well, I'm going to put my finger on this fan blade in a vertical position. So at that point, it is going off, and then once it comes down to here, it goes on, and then off, and then on and off. So it's 2. Yes, it is 2 pulses per revolution. Didn't even need to mark the fan. So, cable tie, in answer to your question, it is 2 pulses.
Push the center out and look in there. Yep.
Yeah.
It's just a round magnet in there. We don't see 2.
Get rid of that. Yeah, okay. Well, yeah, just make a set tape. Yeah, turns out we didn't need it. All I had to do was touch it and push it around with my fingers and
So
we can
2
figure it out.
rotations equals 1 pulse. Or
2 pulses is 1 rotation.
So it'll be
Yes.
half the speed.
Yeah, yeah. But the thing is that the rate of rotation is going to depend on things like the pitch of the blades and all sorts of other things. So it is going to need a calibration process.
Yep.
Where we pass air through an anemometer which is calibrated and gives us a known reading, and then we can see the pulses and the frequency coming out of this fan and see how it corresponds to the actual airflow rate.
Hendrik's asking a good question. I'm
Next
okay for
weekend,
that.
same topic.
If it suits you, or if John got something else in mind.
No, I need to do some more on RepRap Micron next week.
Cool. No worries.
But I'm also months behind on BeetleBot, so I have several things that I want to keep moving on
We
at the
can
moment.
park this one. That's fine.
Yeah,
And
so
I'll
we can
continue
come back
on.
to this.
Yeah.
Yeah, so Gav can do some updates in the meantime. Cable Tie said, yes, hence my earlier question. Do you have a calibrated anemometer on hand? The short answer is not here, but Gav has access to them through his work.
I've got a Fluke one, which is actually right. It's a real proper one. Expensive in a nice plastic safety box.
Yep.
And the JCar version,
Yeah.
which does temperature and does less, but it would be a good idea. Need about 7 Jonos.
You need about 7 ex-Jonos.
Yeah. Maybe.
Maybe.
Maybe. That might not be so good
Okay,
for the
well,
world.
thank you for your help, John.
Yeah, no
I
worries.
thought that was an interesting exercise and something different.
Yeah, that was fun.
Yeah, so-
We got stuff coming up on the scope, and we
Hendrik,
got
thank
code
you so
running, and
much for your
Hendrik
help.
got the code running
Yeah,
on it.
that's really
And
great.
we have actual numbers appearing here in the UI. So, yeah, that was really nice.
That was a bit of an international effort, which is great. And everyone got a free takeaway, not quite exactly what you wanted, HTML page created by Claude. But it's a good
Yep.
starting point. And now you've given me somewhere to go with this, so that's great. It's great.
Oh, Cable Tie says, cool, I have a couple if you need to borrow one. Oh, thanks,
cool.
Cable Tie, that's generous. Yeah, so based on what Gav was saying earlier, it sounds like he's got fairly easy access to the JCar style and the proper Fluke, like calibrated reference one,
Thanks, Gav
not
and
so
John,
much,
for an excellent prep session.
because it's a more expensive thing that, yes, needs to stay
So
where
how
it
many
stays.
pre-apps have I got today, John? How many have we got online?
How many, what's?
How many pre-apps have I got today? Because I normally have about
Pre-apps?
12. And how many have we got in the chat? How many people in the chat?
How many people in the chat?
Yeah, because it's saying it's a prac session. So.
How many people do we have right now? I've got so many windows here. Live streaming. Right now, we've got 31 people.
Okay, so that's twice my normal class. I normally have to handle that on my own. So
Okay.
you've been a great co-teacher today, John.
Oh,
Yes.
thanks, Gav.
I'll
I have learned a little bit
I'll
about
give you your
air
wings.
conditioning.
There you go. You have your trainer wings. Unofficial trainer.
Very nice. All right. So,
It's been good. I've enjoyed it. Thank you.
yeah, thanks for coming along. And
Hope you learned something about how air conditioning works.
yeah,
Gravel
I'm
voice.
gonna end the stream so that I can clear my throat.
Now he sounds awfully like one of those Simpson characters.
All right. Thanks,
Thank you,
everybody.
guys. Thanks for watching.
Have
Appreciate
a
it.
great week. And
Oh yeah, don't forget to do that.
How
Thumbs
much
up
did you
and
pay Gav?
thumbs down. Thumbs
not
up.
enough. No. No, he's fine. It's good.
Okay.
The company is the pleasure, and that is the payment. That's fine.
So yeah, have a great week, and I will see you next time. See ya.
See you guys.